Hello there, and welcome back to Science to Fall Asleep. Tonight, there is nowhere you need to go. There is nothing you need to solve, nothing you need to achieve before the night is over. Instead, let yourself become comfortable, let the room become quieter, and allow your attention to drift gently toward one of the most mysterious and essential things your body does every single day. Sleep. Every night, while the outside world becomes quieter, something extraordinary begins happening inside you. Your brain changes its rhythm. Your breathing gradually becomes slower and more regular. Your muscles relax. Your body temperature shifts. Your hormones change. Your memories are reorganized. Your immune system continues its quiet work. And your brain, despite appearing completely still from the outside, becomes incredibly active in its own hidden way. Sleep is not simply the absence of waking. It is not your brain switching off. It is a carefully organized biological state that has evolved over millions of years. And tonight, we are going to slowly explore 100 fascinating facts about sleep. You do not need to remember them. You do not need to concentrate on every detail. In fact, if your eyes are becoming heavy while you listen, that is perfectly fine. You can simply let the information pass through your mind like distant clouds moving across a dark evening sky. So get comfortable. Let your shoulders soften. Allow your jaw to relax. Take a slow breath in and gently let it go. The night is quiet now, and we can begin. Sleep is one of the most universal behaviors found throughout the animal kingdom. Humans sleep, cats sleep, dogs sleep, birds sleep, elephants sleep, dolphins sleep. Even some animals with very unusual lifestyles have periods that resemble sleep. This tells scientists something important. Sleep is not merely a convenient habit. It is deeply connected to the biology of living organisms. For something that occupies roughly a third of an average human lifetime, sleep is surprisingly mysterious. Scientists have learned an enormous amount about it, yet many questions remain. We know that sleep supports memory, learning, emotional regulation, metabolism, immune function, and many other processes. But we still do not have a single complete explanation for why sleep evolved in the first place. One reason sleep is so fascinating is that it creates a strange biological contradiction. While you sleep, you become less responsive to the outside world. That seems dangerous. A sleeping animal may not notice a predator approaching. A sleeping human may not hear every sound around them. And yet sleep has survived throughout evolution. This suggests that the benefits of sleep must be extraordinarily valuable. Your brain does not simply stop working when you fall asleep. Instead, its activity changes dramatically. Different networks become more or less active. Electrical patterns shift. Communication between brain regions changes. And certain forms of information processing may actually become more organized. The sleeping brain is therefore not an empty brain. It is a brain operating in a different mode. One of the most recognizable changes during sleep is the appearance of different sleep stages. Sleep is broadly divided into non-rapid eye movement sleep and rapid eye movement sleep, usually called REM sleep. These states are different from one another. They have different patterns of brain activity, muscle activity, eye movement, breathing, and heart rate. And throughout a normal night, your brain repeatedly moves through these different states. Sleep therefore behaves less like a single destination and more like a journey. You begin in lighter sleep. Then you move into deeper sleep. Later, you enter REM sleep. Then you may return to lighter stages. The cycle repeats. A typical sleep cycle lasts roughly around an hour and a half. Although the exact duration varies from person to person and from one cycle to another. Across the night, the balance between sleep stages changes. Earlier in the night, deeper slow-wave sleep tends to occupy a larger portion of the night. Later in the night, REM sleep generally becomes more prominent. This is one reason why waking after only a few hours can feel very different from waking naturally after a full night. Your brain has not experienced the same sequence of sleep states. Deep sleep is sometimes called slow-wave sleep because of the characteristic slow electrical activity that appears across large areas of the brain. During this state, your brain waves become much slower and more synchronized. Your body is also deeply relaxed. Your breathing tends to become slower. Your heart rate decreases, and your muscles become less active. This stage is particularly important for physical restoration. Growth hormone secretion is strongly associated with deep sleep, especially in younger people. Growth hormone is involved in processes related to tissue growth, repair, metabolism, and maintenance. So while you are lying still beneath your blanket, your body is not simply resting. It is carrying out maintenance. You could think of sleep as a nightly service period for the body. The outside world may be quiet, but inside you, countless biological processes continue. Your cells are maintaining themselves. Your brain is processing information. Your immune system is active. Your hormonal environment is changing. And your nervous system is moving through carefully coordinated patterns. One of the most interesting things about sleep is that the brain changes its relationship with sensory information. You do not become completely disconnected from the environment. Instead, the brain becomes less responsive to many ordinary signals. This allows you to remain asleep despite small sounds, tiny movements, and other harmless disturbances. Yet important signals can still wake you. A baby crying, a smoke alarm, a sudden unfamiliar noise, or sometimes even your name being spoken. The sleeping brain therefore retains a certain level of environmental monitoring. It simply changes the threshold for responding. This ability is remarkably useful. Imagine if every tiny sound woke you completely. Sleep would become almost impossible. Instead, the brain filters enormous amounts of information while allowing you to remain asleep. Your sense of time also changes during sleep. You can close your eyes at night and feel as though only a few moments have passed before morning arrives. Hours may disappear from your conscious experience. This happens because ordinary waking awareness is greatly reduced. There is no continuous stream of conscious time in the way there is during the day. Instead, there may be dreams, fragments of awareness, brief awakenings, and long periods that leave little or no conscious memory. Sometimes you may wake during the night and believe you have been awake for hours. Yet when researchers measure sleep, they may discover that the person actually spent much of that period asleep. Our subjective experience of time during the night can therefore be surprisingly inaccurate. Sleep also interacts closely with your internal biological clock. Deep inside the brain is a small region called the suprachiasmatic nucleus. It is located in the hypothalamus and plays a central role in regulating circadian rhythms. Your circadian rhythm is roughly a 24-hour biological timing system. It helps coordinate sleep and wakefulness with the cycle of day and night. Light is one of the strongest signals influencing this clock. When light enters your eyes, specialized cells in the retina send information to the brain about environmental brightness. That information helps synchronize your internal clock with the outside world. This is one reason why light exposure at unusual times can affect sleep. Your body is constantly receiving clues about whether it is day or night. Sunlight, artificial lighting, screens, indoor environments, darkness, all of these can influence the signals reaching your biological clock. The hormone melatonin is another major part of this system. Melatonin is produced by the pineal gland, and its production normally rises during darkness. It does not simply act like a knockout switch. Instead, Melatonin helps communicate information about biological night to the body. When evening arrives and light levels fall, melatonin production generally increases. This helps prepare the body for nighttime physiology. The timing of melatonin production varies among individuals. Some people naturally become sleepy earlier. Others naturally become sleepy later. These differences are partly related to individual circadian preferences. You may have noticed that some people seem naturally energetic in the morning, while others become much more alert late at night. These tendencies are sometimes described using terms such as morningness and eveningness. They are influenced by biology, environment, age, and lifestyle. Your sleep need also changes throughout life. Newborn babies can sleep for enormous portions of the day. Their sleep is fragmented and distributed differently from adult sleep. As children grow, their sleep patterns change. Teenagers often experience a biological tendency toward later sleep timing. Adults usually require less total sleep than children. Older adults may experience additional changes in sleep architecture and timing. So there is no single sleep pattern that describes every human being. Sleep is dynamic. It changes with age. It changes with environment. It changes with health. It changes with stress. It changes with activity. And it changes with the demands placed upon the body and brain. One of the strongest biological pressures affecting sleep is something called sleep pressure. The longer you remain awake, the stronger your biological drive to sleep generally becomes. A chemical called adenosine is closely associated with this process. During waking hours, energy is constantly being used by cells. As cellular activity continues, adenosine accumulates in the brain. Increasing adenosine contributes to the feeling of sleepiness. When you sleep, adenosine levels decline. This helps reduce sleep pressure. Caffeine interacts with this system in a fascinating way. Caffeine can bind to adenosine receptors and reduce the sensation of sleepiness. It does not eliminate the underlying need for sleep. Instead, it temporarily interferes with one of the signals associated with sleep pressure. This is why caffeine can make you feel more awake even when your body still needs rest. And because caffeine can remain in the body for several hours, drinking it late in the day can affect sleep in some people. The effects vary considerably from person to person. Some people are highly sensitive to caffeine. Others can drink it relatively late without noticing much immediate disruption. But even when you do not consciously feel affected, sleep architecture can sometimes still change. Sleep deprivation is another fascinating area of sleep science. When you do not get enough sleep, the effects can spread throughout the body. Your attention may decline. Reaction times can become slower. Mood can become less stable. Learning can become more difficult. Decision-making can suffer. And the longer sleep deprivation continues, the more significant the effects can become. One particularly interesting effect is that people who are chronically sleep deprived sometimes underestimate how impaired they are. They may become accustomed to feeling tired. The tired state begins to feel normal. But normal does not necessarily mean optimal. This is why consistently insufficient sleep can be difficult to recognize from the inside. Your brain can adapt to the sensation of fatigue without completely adapting to the consequences. Sleep also plays a powerful role in memory. During the day, you encounter enormous amounts of information. Faces, words, sounds, places, conversations, movements, emotions. Some information is important. Much of it is not. Your brain must somehow determine what deserves to be retained. Sleep appears to help with this process. Memories can be stabilized and reorganized during sleep. This process is sometimes called memory consolidation. It is one reason why sleeping after learning can improve later recall. The sleeping brain appears to revisit patterns of activity associated with experiences from waking life. This does not necessarily mean you replay an entire day like a movie. Instead, specific neural patterns may be reactivated. In this sense, sleep can help transform recent experiences into more stable memories. This is especially fascinating when learning physical skills. If you practice a movement repeatedly, such as playing an instrument, learning a sport, or practicing a new motor sequence, sleep can contribute to improvement. You may wake up feeling as though you did nothing overnight, yet your performance can sometimes be better than it was before sleeping. Your brain has been quietly continuing the work. This is one of the reasons the phrase "sleep on it" has some scientific wisdom behind it. Sleep can also influence problem solving. Sometimes stepping away from a difficult problem allows the brain to process information differently. People occasionally wake with a new perspective or solution. Sleep does not magically solve every problem, but changes in brain activity and memory processing may help connect information in new ways. Dreaming is another remarkable feature of sleep. Most people dream, even if they rarely remember their dreams. Dreams can occur during several sleep stages, although vivid and elaborate dreams are especially associated with REM sleep. During REM sleep, brain activity can become surprisingly similar to waking activity in some regions. Your eyes move rapidly beneath closed eyelids. Your muscles are generally inhibited, and the brain can generate remarkably complex experiences. Dreams can contain places that do not exist, people who are long gone, impossible events, strange combinations of memories, and emotional experiences that can feel completely real while they are happening. Scientists still debate exactly why we dream. There is no single universally accepted explanation. Dreams may be connected to memory processing, emotional regulation, brain development, spontaneous neural activity, or several processes occurring simultaneously. Perhaps one day we will understand them much more clearly. For now, dreams remain one of sleep's most beautiful mysteries. During REM sleep, something called muscle autonomy occurs. This means that most skeletal muscles become temporarily inhibited. This is extremely useful because your dream world can contain movement without your physical body acting out every movement. Imagine dreaming that you are running through a forest. Your brain can construct the sensation of running while most of your actual muscles remain still. The body is essentially separating imagined movement from physical movement. This system is not perfect, and certain sleep disorders can disrupt the normal boundaries between dreaming and movement. But under ordinary circumstances, REM-related muscle inhibition provides an important layer of protection. Your breathing during sleep also changes. It becomes more automatic and generally slower. The brainstem contains networks that help regulate breathing without conscious effort. You do not need to remind yourself to breathe while asleep. You do not need to set an alarm in your mind saying, "Take another breath." Your nervous system handles it automatically. This is one of the most remarkable things about sleep. You surrender conscious control while fundamental biological systems continue operating. Your heart continues beating. Your lungs continue exchanging gases. Your kidneys continue filtering blood. Your liver continues performing metabolic functions. Your immune system continues monitoring the body. The body never truly stops. Sleep simply changes the operating environment. Body temperature also follows a daily rhythm. Core body temperature generally decreases during the biological night. This decline is part of the body's preparation for sleep. The cooler environment can therefore support the natural process of falling asleep. This is one reason many people find a slightly cool bedroom comfortable. Your body is also remarkably sensitive to temperature. Too hot, and sleep can become uncomfortable. Too cold, and the body may need to spend more energy maintaining temperature. A comfortable thermal environment can make it easier to remain asleep. Sleep position is another interesting subject. Humans sleep in many different positions. On the back, on the side, on the stomach, curled up, spread out. There is no single position that every human naturally prefers. Individual anatomy, habits, culture, comfort, and physical conditions all influence sleep posture. And while you may fall asleep in one position, you can change positions many times throughout the night without remembering doing so. These small movements are normal. They help relieve pressure on tissues and maintain comfort. Most people do not remain perfectly still for 8 hours. Instead, sleep contains subtle movement. A turn of the head, a shift of the shoulder, a bend of the leg, a brief adjustment of the blanket. Sometimes you may even wake for a moment and not remember it the next morning. Brief awakenings are common. In fact, sleep is not always one perfectly uninterrupted state. You may experience tiny periods of arousal between sleep cycles. The brain can briefly become more alert before returning to sleep. Most of these events never enter conscious memory. This is why a person can honestly say, "I slept all night," even though their brain may have briefly awakened several times. Sleep is therefore more dynamic than it feels. Another fascinating feature of sleep is that your brain maintains a kind of internal surveillance system. Important changes in the environment can trigger arousal. A familiar bedroom sound may be ignored. A strange sound may wake you. This is sometimes called the first night effect in sleep research, where unfamiliar environments can produce altered sleep patterns and greater monitoring. When you sleep somewhere unfamiliar, part of the brain may remain more vigilant. The brain is essentially asking, in its own biological way, whether the environment is safe. Once the environment becomes familiar, sleep may become deeper and more stable. The need for safety during sleep makes sense from an evolutionary perspective. A sleeping organism is vulnerable. Therefore, sleep had to evolve alongside mechanisms that allow the brain to monitor potential threats. This balance between vulnerability and restoration is one of the central mysteries of sleep biology. Animals have developed different strategies for achieving it. Some sleep in groups. Some sleep in protected locations. Some sleep for very short periods. Some can sleep while maintaining partial awareness of their surroundings. Dolphins provide one of the most famous examples. They can engage in a form of unihemispheric sleep, in which one hemisphere of the brain is less active while the other remains more alert. This allows them to continue surfacing for air. Their biology demonstrates that sleep does not have to look exactly the same across species. Birds can also display unusual sleep strategies. Some birds can sleep while maintaining remarkable control over their posture. Migratory birds have evolved complex relationships between sleep, activity, and long-distance travel. Elephants, meanwhile, can function with surprisingly little sleep compared with many other mammals. Small animals can have very different sleep patterns. This variety suggests that sleep is highly adaptable. There is no universal biological formula saying that every animal must sleep in exactly the same way. Instead, sleep has been shaped by ecology, metabolism, predators, environment, social behavior, and evolution. Even humans have adapted our sleep patterns to different environments and lifestyles. Before artificial lighting, natural darkness played a much greater role in human daily rhythms. The invention of electric lighting dramatically changed our relationship with night. Humans gained the ability to remain active long after sunset. Cities became brighter. Work schedules became more flexible. Entertainment continued throughout the night. And eventually, digital screens brought light directly into our bedrooms. The modern world, therefore, gives us extraordinary control over our environment. But our biological clocks still evolved under conditions very different from today's. Your brain may understand that it is midnight. Your body may still receive light from a television, phone, lamp, or computer. This can create a mismatch between environmental signals and biological timing. Blue-enriched light is particularly effective at influencing the circadian system because the retinal cells involved in circadian signaling are especially sensitive to shorter wavelengths. This does not mean that every screen automatically destroys sleep. The effect depends on brightness, timing, duration, distance, individual sensitivity, and other factors. But light is unquestionably one of the most powerful environmental signals influencing your biological clock. Darkness, on the other hand, is a strong signal that biological night has arrived. This is why a dark bedroom can be so comfortable for sleep. Your brain receives fewer visual signals telling it that daytime activity is continuing. The darkness allows the natural nighttime system to operate with fewer interruptions. Sound matters too. A completely silent room is not necessary for everyone. Some people sleep better with gentle background sounds. Rain, fans, white noise, soft environmental sounds. These can sometimes mask sudden changes in the environment. The important factor is often predictability. A sudden, unpredictable sound is more likely to attract attention than a steady, familiar sound. This is one reason consistent background noise can be soothing for some people. Sleep and emotions are also deeply connected. When you are well rested, emotional regulation tends to be easier. When you are exhausted, small problems can feel larger. Irritation can appear more quickly. Stress can feel more intense. And emotional reactions may become harder to control. Sleep does not simply restore the body. It helps regulate the brain systems involved in emotion. This relationship works in both directions. Stress can make sleep more difficult, and poor sleep can make stress feel stronger. A difficult night can therefore create a cycle. You worry because you cannot sleep. Then the worry makes it harder to sleep. The next day you feel exhausted, and that exhaustion can increase emotional tension the following night. Learning to approach bedtime without excessive pressure can sometimes help break that cycle. Sleep is not something you can force in the same way you can force yourself to lift a weight. The more intensely you demand that you fall asleep immediately, the more alert you may become. Sleep often arrives more naturally when the body feels safe and the mind is allowed to become less engaged. This is why relaxing bedtime routines can be useful. The brain learns associations. If you repeatedly create a quiet, comfortable environment before bed, those cues can become connected with sleep. Over time, the bedroom itself can become a powerful signal that it is time to rest. This is one reason sleep researchers often recommend using the bed primarily for sleep and other restful activities. The brain is constantly learning what places mean. A bed associated with work, arguments, intense entertainment, or prolonged frustration may develop different associations than a bed consistently associated with calmness and sleep. Your bedroom can become a psychological cue. Darkness, quiet, cool temperature, comfort, familiarity. Together, these signals tell your nervous system that the day is ending. And eventually, perhaps without conscious thought, the body begins to respond. Your eyelids become heavier. Your thoughts become less organized. Your muscles loosen. The world around you becomes less important. And the transition begins. The first stage of non-REM sleep is relatively light. It is the bridge between wakefulness and sleep. Your muscles begin to relax. Your eye movement slow. Brain activity changes. And you become easier to wake. Sometimes people experience strange sensations while entering this stage. A sudden feeling of falling. A brief muscle jerk, a flash of imagery, a sound that seems to come from nowhere. These experiences can be startling, but many are ordinary features of the transition between wakefulness and sleep. One of the most common is the hypnic jerk. You may suddenly feel as though you are falling, and your body may make a quick involuntary movement. Scientists have proposed several explanations for this phenomenon. One idea is that it may represent a misinterpretation of muscle relaxation by the brain. Another possibility is that it reflects an ancient protective reflex. There is no single definitive explanation, but the experience itself is very common. It can happen just as you are drifting away from conscious awareness. And then, almost without noticing, you cross the boundary. You are asleep. The room is still there. The bed is still beneath you. The night continues, but your conscious relationship with the world has changed. This transition is one of the most ordinary and extraordinary experiences humans share. Every night, billions of people around the planet perform the same biological journey. Different languages, different cultures, different homes, different lives. Yet almost everyone eventually closes their eyes and enters sleep. Sleep is therefore one of humanity's great shared experiences. It connects us to every human who has ever lived. Ancient people slept beneath stars. Farmers slept after long days in fields. Sailors slept aboard wooden ships. Travelers slept beside roads. Children slept in crowded homes. Scientists sleep. Artists sleep. Musicians sleep. Astronauts sleep. Even the people who changed history needed to spend part of their lives unconscious. No matter how important the day feels, the human body eventually asks for rest. Sleep is a reminder that biology places limits on ambition. You can postpone sleep for a while. You can resist tiredness. You can consume stimulants. You can continue working. But eventually the biological need for sleep becomes difficult to ignore. The body keeps its own schedule. And tonight, as you listen, perhaps your own body is quietly beginning to make that request. A little less stimulation. A little more darkness, a little more stillness, a little more quiet. Your breathing continues, slowly, naturally, without effort. And while you listen to these facts, you do not need to hold on to every word. The purpose of tonight is not to memorize sleep science. It is simply to let your mind wander gently through it. So if a thought appears, let it appear. If another thought disappears, let it disappear. You do not need to chase it. You do not need to solve anything. The night can continue without your supervision. Your brain knows how to sleep. It has been practicing this process for your entire life. And perhaps that is one of the most comforting facts about sleep. You do not have to consciously perform it. You simply create the conditions. Then your biology takes over. The lights become dim. The muscles relax. The breathing settles. The heart continues its quiet rhythm. The brain begins shifting its patterns, and consciousness gradually becomes less important. Soon, the outside world may begin to feel distant. The words may become softer. The spaces between them may become longer. And somewhere inside the darkness, your brain may begin preparing for another long journey through the night. There is still so much more to discover. Sleep affects appetite. It influences hormones. It interacts with exercise. It affects learning. It influences creativity. It changes how we respond to stress. It shapes memory. It interacts with aging. It influences immune activity. It even affects how we perceive the passage of time. And beneath all of these effects lies a fascinating biological architecture that scientists are still uncovering. So for now, let yourself become comfortable. You can keep listening, or you can allow yourself to drift away. There is no requirement to reach the end. There is no quiz waiting for you. No test. No assignment. Nothing you need to remember tomorrow. If your attention wanders, that is perfectly fine. If you hear only fragments, that is fine too. And if you fall asleep before the next thought arrives, then perhaps the story has already done exactly what it was meant to do. The night is here. Your body knows what to do. And slowly, gently, naturally, you can let yourself rest. As the night grows quieter, sleep begins to reveal another side of itself. One of the most remarkable things about sleep is that it is closely connected to the way your body manages energy. While you are awake, your body is constantly responding to the outside world. You move, you think, you speak, you eat, you make decisions, you react to sounds and images. All of this requires energy. During sleep, many of those demands become smaller. Your muscles are mostly still. Your environment requires less attention, and the brain can devote more resources to internal processes. This does not mean that energy use stops. The sleeping brain remains metabolically active, but the balance changes. The body is no longer spending as much energy responding to the outside world. Instead, much of its activity is directed toward maintenance and regulation. This is one reason sleep can be thought of as a period of biological housekeeping. Your brain also produces waste products as a natural consequence of its activity. During sleep, the movement of fluid through the brain appears to increase, helping support the clearance of certain metabolic waste products. Scientists often discuss this in connection with the glymphatic system. The details are still being investigated, but the general idea is fascinating. Your brain has mechanisms for moving fluid through its tissues and helping clear substances produced during normal metabolism. Sleep appears to be an important part of this process. So while your conscious mind is resting, the brain may be performing its own quiet cleanup. It is almost as though the lights are off in a building while maintenance workers move through the hallways. The building looks inactive from outside, but inside, important work continues. Sleep is also deeply connected to the immune system. Your immune system is constantly monitoring your body for potential threats. It identifies damaged cells, responds to pathogens, coordinates inflammation, and remembers certain previous encounters. Sleep interacts with many of these processes. When you sleep poorly, some aspects of immune function can become disrupted. And when the body is fighting an infection, sleep patterns can change. You may feel unusually sleepy when you are sick. That increased desire to sleep may be part of the body's broader response to illness. During infection, immune signaling molecules can influence the brain. The result can include fatigue, changes in appetite, changes in body temperature, and increased sleepiness. This means that the desire to sleep when you are ill is not simply weakness. It is connected to biology. Your body may be redirecting resources toward recovery. Sleep also interacts with inflammation. Inflammation is essential when properly controlled. It helps the body respond to injury and infection. But excessive or poorly regulated inflammation can become harmful. Sleep and immune regulation are closely intertwined, and researchers continue studying exactly how these relationships work. The connection becomes especially interesting when we consider that sleep itself can be affected by illness. A fever can change sleep. Pain can interrupt sleep. Coughing can interrupt sleep. Congestion can make breathing uncomfortable. The body may want more rest while simultaneously finding it harder to obtain high-quality sleep. This creates an unusual biological contradiction. You may need sleep more than ever precisely when your body makes sleep more difficult. Another important relationship exists between sleep and appetite. Your body has several hormones and neural systems involved in regulating hunger and fullness. Sleep influences these systems. Insufficient sleep can affect signals related to appetite and food intake. When you are exhausted, highly palatable foods can sometimes become more tempting. This is partly because sleep loss can influence the brain's reward systems. The tired brain may seek quick sources of pleasure or energy. This is one reason sleep can indirectly influence eating behavior. It is not simply a matter of willpower. Biology plays a role. Your body is trying to understand why it feels depleted. Sleep therefore participates in the broader system that regulates energy balance. This is another reminder that sleep is connected to almost everything. It is not isolated from nutrition. It is not isolated from exercise. It is not isolated from emotions. It is not isolated from metabolism. The body operates as one interconnected system. A change in one part can influence another. Exercise and sleep have an especially interesting relationship. Regular physical activity is generally associated with healthier sleep patterns. Movement during the day can increase the body's need for recovery. Exercise also affects mood and stress. Both can influence how easily you fall asleep. But timing matters. Intense exercise immediately before bedtime may make some people feel more alert because body temperature, heart rate, and nervous system activity remain elevated for a while. Other people can exercise late in the evening without much trouble. Again, biology varies. There is no single perfect schedule for every person. Your body has its own rhythm. Sleep also affects physical performance. Athletes often pay enormous attention to sleep because recovery is essential to performance. Reaction time, coordination, decision-making, muscle recovery, mood, motivation, all can be influenced by sleep. A well-rested athlete may be better prepared to perform than an exhausted one. This is why sleep has increasingly become recognized as part of training rather than merely time away from training. Rest is not the opposite of preparation. Rest is part of preparation. The same idea applies to learning. Imagine spending an entire afternoon studying. You read, you review, you practice, you repeat, then you sleep. The next morning, some of what you learned may be easier to remember. Sleep did not replace studying. It helped the brain process what happened during studying. This is why cramming through an entire night can sometimes be counterproductive. Staying awake longer gives you more immediate study time, but sacrificing sleep can interfere with memory consolidation and attention. The brain needs both learning and recovery. Sleep is therefore not wasted time. It is part of the learning process. There is another fascinating feature of memory. Not everything you experience during the day deserves to be remembered. Imagine if you permanently stored every face you passed on the street, every license plate, every word you heard, every sound from a nearby room, every movement you made, every advertisement, every random thought. Your brain would become overwhelmed with unnecessary information. Instead, memory involves selection. Sleep may help strengthen some memories while allowing others to fade. In this sense, forgetting can be useful. A healthy memory system is not one that remembers everything. It is one that remembers what matters. Sleep may contribute to this process by changing the strength of different neural connections. The sleeping brain is not simply preserving memories. It may also be reorganizing them. This can help explain why memories sometimes feel different after sleeping. A confusing experience may become clearer. A sequence of information may become more organized. A difficult skill may feel slightly easier. The brain has been quietly working in the background. Sleep can also influence creativity. Creative thinking often depends on connecting ideas that are not obviously related. During sleep, the brain can make unusual associations. This may help explain why people sometimes wake with unexpected ideas. Famous discoveries and creative insights have occasionally been associated with dreams or sleep. But we should be careful. Sleep does not guarantee inspiration. It simply creates a different mental environment in which information can be reorganized. The sleeping brain is less constrained by the demands of immediate reality. This may allow unusual connections to emerge. Dreams demonstrate this beautifully. One moment you may be walking through your childhood home. The next, you are floating above an ocean. Then suddenly you are speaking with someone you have not seen in years. Dream logic does not have to follow waking logic. Time can bend. Places can merge. People can change. Objects can become something else. And somehow, while dreaming, all of this may feel completely normal. The brain is capable of constructing entire environments from internal activity. Dreaming, therefore, offers a glimpse into the brain's incredible ability to generate reality-like experiences. You do not need external scenery to experience a landscape in a dream. You do not need an actual conversation to hear someone speaking. You do not need a physical journey to feel that you are traveling. Your brain can create an internal simulation. This is one of the deepest mysteries of consciousness. Where does the feeling of being somewhere come from? How does the brain create the sensation of seeing? How does it produce sounds without external sound? How can emotions appear so powerfully during sleep? Science has many theories, but the full explanation remains incomplete. Some dreams are forgotten almost immediately. Others remain vivid for years. The difference may depend partly on whether you wake during or shortly after dreaming. Dream memories can disappear quickly because the brain systems responsible for forming stable long-term memories are operating differently during sleep. If you wake during REM sleep and remain awake for a few moments, you may remember a detailed dream. If you sleep through the transition, the dream may vanish. This is why people sometimes say they had an amazing dream but cannot remember what happened. The dream may have felt enormous, yet only a few minutes later, it is gone. Dream forgetting is so common that most people probably experience far more dreams than they remember. You may have dozens of dream experiences across a week and remember only a handful. In this sense, your sleeping mind may be far more active than your morning memory suggests. Dreams are also not necessarily visual for everyone. People can experience dreams involving sound, movement, emotion, touch, and other sensations. Individuals with visual impairments can dream as well. The content of dreams can reflect the sensory experiences available to the dreamer. This demonstrates that dreaming is not simply the brain playing imaginary movies. It is a broader simulation of experience. Sleep can also influence how we process emotional memories. During REM sleep, emotional experiences may be revisited in a different neurochemical environment. Scientists have proposed that this could help reduce the emotional intensity associated with certain memories over time. The exact mechanism is still being studied, but the relationship between REM sleep and emotional processing is increasingly important in sleep research. This may help explain why a difficult emotional experience can sometimes feel different after a night of sleep. Time alone may contribute, but sleep may also be part of the process. The brain is constantly updating its interpretation of the past, and sleep provides one of the periods when that updating can occur. Your emotional world is therefore not fixed. Memories change, associations change, reactions can change, and sleep may participate in that gradual transformation. Another fascinating feature of sleep is its relationship with stress hormones. Cortisol is one of the body's major stress-related hormones. It follows a daily rhythm. Normally, cortisol tends to rise toward the morning, helping prepare the body for waking and activity. Later in the day, levels generally decline. This rhythm is part of the body's preparation for the transition between sleep and wakefulness. In a healthy circadian system, your body is not simply waiting for you to wake. It is preparing you to wake. Your temperature begins rising. Hormonal signals change. Brain activity shifts, and your biological systems gradually transition toward daytime function. Morning, therefore, begins before you consciously open your eyes. Your body starts preparing for it while you are still asleep. This is why waking naturally can sometimes feel very different from being suddenly awakened by a loud alarm. When you wake naturally, several biological systems have already begun transitioning. When an alarm interrupts sleep unexpectedly, the transition can feel abrupt. This does not mean alarms are inherently harmful. They are useful tools, but your biological clock has its own timing. And when that timing aligns with your schedule, waking can feel easier. Morning light is particularly powerful in this regard. Exposure to bright light after waking can help reinforce the circadian signal that daytime has arrived. This is one reason natural daylight can be useful for maintaining a stable sleep-wake rhythm. The sun has been regulating life on Earth for billions of years. Human biology evolved under its cycle: day, night, light, darkness, wakefulness, sleep. The modern world has introduced many new signals: artificial lights, electric clocks, phones, computers, late-night entertainment, shift work, global travel. These inventions are remarkable, but the brain still relies on ancient biological mechanisms. Your internal clock does not know that you have an important meeting tomorrow. It simply responds to biological signals: light, darkness, activity, food timing, temperature, social schedules. These signals collectively help synchronize your daily rhythms. Travel across time zones reveals just how powerful the circadian clock is. When you fly from one part of the world to another, the sun may rise and set according to a completely different schedule. But your internal clock does not immediately adjust. For a while, your body may continue operating according to the old timing. This mismatch is known as jet lag. You may feel sleepy during the day, awake at night, hungry at unusual times, or simply out of rhythm. Over several days, your biological clock gradually adjusts to the new environment. The speed varies among individuals and depends on the direction and size of the time zone shift. Travel, therefore, provides a natural experiment demonstrating that your body contains an internal clock. Shift workers experience a similar challenge. Working at night and sleeping during the day requires the body to operate against the usual environmental cycle. Some people adapt better than others, but maintaining sleep quality can be difficult when biological signals and work schedules conflict. The human body is incredibly adaptable, yet adaptability has limits. This is another reason sleep science is important in modern society. Our biology evolved in a world of natural cycles. Our lifestyles can now operate around the clock. The two systems do not always cooperate perfectly. Sleep also changes with seasons. In areas where daylight duration varies greatly, people may experience changes in sleep timing and mood. Even where seasonal changes are smaller, shifts in daylight can still influence circadian rhythms. The human body pays attention to the length and timing of light exposure. Your biological clock is not simply a stopwatch. It is an environmental timing system. It constantly compares internal rhythms with external cues. This process is called entrainment. The goal is alignment. Your internal day should roughly match the external day. When the signals are consistent, sleep and wakefulness can become predictable. When signals are chaotic, the system can become less stable. This is why consistent sleep schedules can be helpful. Going to bed at wildly different times each night can make it harder for your body to predict when sleep should occur. A regular rhythm provides the brain with repeated information. The body begins to anticipate sleep. Eventually, sleepiness may arrive around the same time each evening. This does not mean you must live by an exact minute. Biology is flexible, but consistency can provide useful structure. The bedroom environment matters too. Temperature, light, noise, comfort. Even the smell of the room can influence associations. Your brain is constantly learning. A familiar scent can remind you of a place. A particular sound can signal safety. A certain room can make you feel relaxed. Sleep benefits from this learning process. Your brain can associate the bedroom with rest. Over time, simply entering that environment may begin to trigger relaxation. This is one reason routines can be powerful. A warm shower, dim lighting, quiet music, reading, gentle stretching, breathing slowly. These activities can become signals that the day is ending. The specific routine is less important than the consistency. Your brain learns patterns, and sleep thrives on predictable patterns. There is also something wonderfully simple about darkness. For most of human history, darkness meant the day was ending. The world became quieter. Activity slowed. Temperature changed. Predators and prey behaved differently. Humans gathered around firelight. Eventually, sleep arrived. Today, darkness is no longer guaranteed. A city can remain bright all night. Buildings can glow. Streetlights can illuminate windows. Screens can shine beside the pillow. But when you reduce unnecessary light, you recreate one of the oldest environmental signals your brain understands. Night has arrived. You are safe. You can rest. And perhaps that simple message is one of the most powerful signals in the entire sleep system. As you lie here now, your body is continuing its own quiet calculations. It is sensing the darkness, feeling the stillness, tracking your internal clock, responding to the day's accumulated sleep pressure, and gradually deciding that wakefulness is no longer necessary. You do not have to command this process. You can simply allow it. Your thoughts may become slower. The edges of ideas may become softer. A sentence may begin and disappear before it reaches its end. That is okay. You are not supposed to hold on to everything. The purpose of sleep is not to remain alert. It is to let go of alertness. So if you notice your attention drifting, you can simply let it drift. If your eyes are closed, keep them closed. If you are already comfortable, there is nothing else you need to adjust. The night can carry on around you, and inside your brain, another sleep cycle may soon begin. The quiet architecture of sleep is waiting. Slow brain waves, changing hormones, reduced sensory awareness, memory processing, emotional regulation, cellular maintenance, immune activity, and countless processes too subtle for conscious awareness. You may never notice most of them, and perhaps that is part of the beauty. The body performs its most important work without asking for your attention. You do not need to watch your heart beating. You do not need to supervise your breathing. You do not need to direct every cell. And you do not need to manage sleep. Your biology already knows the way. So let the night become darker. Let the room become quieter. Let the remaining thoughts move farther away. Tomorrow can take care of tomorrow. Tonight belongs to rest. And somewhere between one thought and the next, your waking mind can gradually become quieter. The story can continue. The facts can continue. But you do not have to continue listening. You are allowed to drift. You are allowed to forget. You are allowed to sleep. The deeper we move into the night, the more fascinating sleep becomes. Because beneath the simple experience of closing your eyes lies an enormous biological system, quietly coordinating your brain, your body, your memories, your hormones, and even your sense of time. And perhaps the strangest part is that most of this happens without you noticing. You simply lie down. You become comfortable. You close your eyes. And gradually, the waking world begins to fade. But inside your brain, the night is only beginning. One of the most remarkable things about sleep is that the brain can temporarily change the way different regions communicate with one another. During wakefulness, your brain is constantly integrating information. You see something, you hear something, you feel something, You think about it. You compare it with memories. You decide what to do. Sleep changes this pattern. Different networks become more or less synchronized depending on the stage of sleep. During deep sleep, slow electrical waves can travel across large areas of the brain. These waves are sometimes described as traveling patterns of neural activity. They represent periods when large groups of neurons become active and quiet together. The rhythm is slow, steady, and deeply connected with the restorative character of deep sleep. You could imagine the brain as a vast city at night. During the day, thousands of roads are busy. Messages are moving constantly. Signals are arriving from everywhere. Then nighttime arrives. Traffic becomes lighter. Some roads become quiet. Other systems begin maintenance. And the entire city develops a different rhythm. The city has not shut down. It has simply changed its pattern of activity. Your brain behaves in a surprisingly similar way. During deep sleep, the slow waves can help coordinate communication between distant brain regions. This coordination is thought to contribute to memory processing. Information stored temporarily in certain brain structures may interact with more distributed networks. The hippocampus is particularly important in this process. It plays a major role in forming and organizing new memories. During waking hours, the hippocampus can rapidly encode information about experiences. During sleep, patterns associated with those experiences may be replayed. Scientists have observed neural activity that resembles compressed versions of waking experiences. A rat exploring a maze, for example, can show patterns of hippocampal activity during later sleep that resemble patterns observed while it was navigating. This phenomenon is often called replay. It provides fascinating evidence that the brain may revisit recent experiences during sleep. Imagine walking through a new neighborhood during the afternoon. You notice a street, a building, a turn, a familiar landmark. Later, while you sleep, the brain may quietly revisit aspects of that experience, not necessarily as a conscious dream. Instead, the information may be replayed at the level of neural activity. The brain is essentially reviewing its recent experiences without requiring your conscious participation. This may help strengthen useful information. It may also help integrate new experiences with older knowledge. Sleep therefore becomes a bridge between yesterday and tomorrow. What happened during the day does not simply disappear when you fall asleep. Some of it is carried forward. Some is reorganized. Some is weakened. Some is integrated into larger patterns of knowledge. And some is probably discarded. The brain is constantly deciding what deserves to remain. This process is one reason sleep can change your relationship with memories. A memory that feels vivid one night may feel less emotionally powerful after several nights of sleep. Other memories become more stable. Some details disappear. The overall meaning may remain. The brain is not simply recording life. It is interpreting life. And sleep may provide an important period for that interpretation. Another fascinating idea in neuroscience is synaptic homeostasis. During waking hours, your brain is exposed to an enormous number of experiences. Neurons communicate with one another through synapses. These connections can become stronger as you learn and experience things. But if every synapse became stronger all the time, the system would eventually become inefficient. The brain needs balance. One proposed role of sleep is to help regulate the overall strength of synaptic connections. During sleep, some connections may be weakened while important patterns are preserved. This could help maintain efficiency. Think of it like organizing a room. During the day, you place objects everywhere. Some are important, some are temporary, some are not needed. At night, the room is reorganized. The goal is not to remove everything. The goal is to make the environment functional again. Your brain may perform a similar form of organization. Sleep may therefore help prevent neural networks from becoming overloaded. It may also improve the signal-to-noise ratio of important information. The brain needs to remain flexible. Too little connection would make learning difficult. Too much indiscriminate strengthening could make the system inefficient. Sleep may help maintain the balance. Another fascinating feature of sleep is the way your body controls muscle tone. During wakefulness, your muscles receive continuous signals from the nervous system. You can decide to stand, walk, reach, smile, turn your head. During REM sleep, much of this voluntary muscle activity is suppressed. The brainstem sends signals that inhibit many spinal motor neurons. This creates the temporary muscle paralysis associated with REM sleep. The result is extraordinary. Your brain can construct elaborate movements without your body physically performing them. You may dream that you are running, yet your legs remain mostly still. You may dream that you are swimming, yet you do not actually swim through your bedroom. You may dream that you are flying, yet your body remains safely beneath the blanket. The dream world is therefore largely disconnected from physical movement. The brain creates the experience. The body remains quiet. This is one of the most elegant protective systems in sleep biology. REM sleep also produces rapid eye movements. These movements occur beneath closed eyelids. Scientists have studied them for decades. There is still debate about exactly what every eye movement represents. Some research suggests that certain eye movements may correspond to changes in the direction of attention within dreams. Other interpretations are more cautious. What we know for certain is that REM sleep is a highly active physiological state. The brain is active, the eyes move, the muscles are largely inhibited, breathing can become more variable, heart rate can fluctuate, and vivid dreams are common. REM sleep is therefore sometimes described as a paradoxical state. The brain resembles wakefulness in certain ways while the body remains deeply asleep. It is a strange combination. The mind appears active, the body remains still, and consciousness takes on forms that would be impossible during ordinary waking life. Another unusual feature is that REM sleep can produce changes in autonomic activity. Heart rate and breathing may become less regular than during deep non-REM sleep. The body is not necessarily in a uniformly relaxed physiological state. Instead, it is moving through a different pattern of regulation. This is why sleep cannot simply be described as rest. Different stages involve different biological conditions. Some are associated with profound physical restoration. Others involve intense brain activity. Others sit between waking and deeper sleep. Together, they create a repeating architecture. A normal night is therefore a sequence of changing physiological states. And the sequence matters. If you wake repeatedly, you may not experience the same distribution of sleep stages. You might spend less time in deeper sleep, or less time in REM sleep. The result can be a night that technically contains several hours of sleep, but does not feel as restorative. Sleep quality is therefore not simply a matter of counting hours. Duration matters enormously, but continuity and architecture matter too. This is one reason someone can spend a long time in bed and still wake feeling exhausted. Time in bed is not identical to time asleep. And time asleep is not identical to healthy sleep architecture. Your body needs enough opportunity to move naturally through its stages. Sleep cycles are not perfectly identical. The first cycle of the night may contain a larger amount of deep sleep. Later cycles often contain more REM sleep. This changing architecture means that the final hours of a normal night's sleep can be particularly rich in REM. This is one reason repeatedly cutting the end of the night short may disproportionately reduce REM sleep. The same is true in reverse. If you sleep longer than usual, you may experience additional REM-rich periods toward the end of the night. This is one of the reasons people often remember vivid dreams after sleeping late. They may have awakened closer to the end of a REM period. The dream itself did not necessarily become more intense. The timing of waking made the memory more accessible. Dream recall is therefore influenced by when you wake. You can dream without remembering. You can also remember a dream because you woke at exactly the right moment. The difference may be only a few seconds. Sleep is filled with these tiny transitions. A person may awaken briefly, look at the clock, turn over, and fall asleep again. The next morning, they may have no memory of any of it. Other awakenings are longer. You may become aware of the room. You may hear a sound. You may think about tomorrow. Then you may gradually drift back towards sleep. This transition between wakefulness and sleep can sometimes be surprisingly delicate. The more attention you place on it, the more awake you can become. This is why clock watching can be unhelpful for some people. You wake, you look at the clock, you realize it is 3:17. Then you calculate how many hours remain. You think about how tired you will be tomorrow. You calculate again. The brain becomes more alert. A simple glance at the clock has turned into a mental problem. Sleep prefers fewer problems. The brain needs permission to stop calculating. Sometimes the most useful thing is simply to allow the night to pass without measuring every minute. There is nothing magical about a particular number on a clock. Your body does not care whether it is 2:41 or 2:42. It cares about biological conditions: darkness, safety, comfort, sleep pressure, circadian timing, and the gradual reduction of alertness. This is why creating a calm environment can be more useful than constantly trying to force sleep. Your brain is designed to recognize patterns. If every night begins with bright lights, stimulating entertainment, stressful conversations, and intense mental activity, the brain receives signals that the day is still happening. If the evening gradually becomes quieter, the signals change. The brain begins to understand. Activity is ending. Rest is approaching. This transition can be surprisingly powerful. A bedtime routine does not need to be complicated. Even simple repeated cues can become associated with sleep. Dim lights, quiet music, a familiar blanket, a few pages of a book, a slow breathing pattern, a peaceful room. Over time, these things can become part of your personal sleep language. Your brain learns what they mean. They mean the day is ending. One of the most interesting aspects of sleep is that it is influenced by learning. You learn not only facts and skills, you can also learn associations. If you repeatedly fall asleep in a particular environment, that environment becomes a cue. If you repeatedly become frustrated in bed while trying desperately to sleep, the bed can become associated with frustration instead. This is why behavioral approaches to insomnia often focus on rebuilding the association between bed and sleep. The goal is not to force sleep. It is to allow the bed to become a place where sleep naturally occurs. This principle demonstrates how deeply psychological learning and biological sleep are connected. The brain does not separate body from environment as neatly as we sometimes imagine. Your surroundings become part of your internal expectations. The bedroom can become a signal. Darkness can become a signal. The time of evening can become a signal. Even the feeling of getting under a blanket can become a signal. Your brain is constantly predicting what will happen next, and sleep can become one of those predictions. Another fascinating feature of sleep is that your ability to awaken can depend on the stage of sleep you are in. Waking from deep slow-wave sleep can produce something called sleep inertia. You may feel confused, heavy, slow, unfocused. Your thoughts may seem to move through fog. This does not necessarily mean you slept badly. Sometimes you have simply awakened during a deep stage of sleep. Sleep inertia can last for varying amounts of time. It may be brief, or it can linger, The feeling is partly related to the fact that the brain does not instantly transition from deep sleep to full alertness. Waking is a process. The brain must increase activity. Attention must return. Body systems must shift. Hormones change. Circulation adjusts. And consciousness gradually reappears. This is why the first few moments after waking can feel strange. You are crossing another biological boundary. The difference is that this time you are moving from sleep toward the waking world. The transition can be gentle when it happens naturally, or abrupt when something suddenly wakes you. A loud alarm, a phone call, a bright light, a sudden noise. These signals can interrupt sleep before the brain has completed its transition. Again, this does not mean alarms are inherently bad. They are often necessary, but the experience demonstrates how carefully organized the natural waking process can be. Your body begins preparing for morning before you become consciously aware of morning. This preparation includes changes in hormones, body temperature, metabolism, and brain activity. Your biological clock is essentially setting the stage. When you finally open your eyes, much of the preparation has already occurred. Morning is not a single event. It is a gradual biological sunrise. The same is true of nighttime. Sleep does not begin the instant your head touches the pillow. The transition begins before that. Your body starts slowing down. Your alertness decreases. Melatonin may rise. Temperature begins to shift. Sleep pressure accumulates. Your thoughts become less focused. Then the boundary between wakefulness and sleep becomes thinner, and eventually you cross it. This gradual transition is one of the reasons rushing into bed immediately after intense activity can sometimes make sleep difficult. The nervous system may still be activated. The body may still be warm. The mind may still be processing information. A short period of quiet can give the system time to change modes. This is not about perfection. It is about allowing biology enough space to do what it naturally does. Sleep is not a button. It is a process. And the more gently you approach it, the easier that process can become. There is another beautiful aspect of sleep. Your perception of yourself becomes less rigid. During waking life, you have a continuous sense of identity. You know where you are. You know what day it is. You know what you are doing. You remember what happened earlier. As sleep deepens, this continuous self-model becomes less prominent. You may lose awareness of the room. You may lose awareness of your body. You may lose awareness of time. Eventually, conscious experience may become extremely minimal, and yet the brain remains active. This creates a fascinating question. What exactly makes consciousness disappear during sleep? Scientists have studied this for decades. It is not simply that the brain becomes inactive. Instead, communication between different regions changes. The information necessary for maintaining a unified conscious experience may become less integrated. The result is a different state of awareness. This is one reason sleep research also contributes to the broader scientific study of consciousness. To understand consciousness, scientists can examine what happens when it changes. Sleep gives us a naturally recurring example. Every night, your conscious experience transforms. You go from a state of rich awareness to reduced awareness, then perhaps into dreams, then back again. And this happens without you having to consciously initiate it. Sleep therefore provides a daily reminder that consciousness is not fixed. It can change, it can fade, it can return, and it can take completely different forms. The sleeping brain is also capable of responding selectively to information. Researchers have found that some sensory information can still influence sleeping people. A familiar sound may be ignored. A meaningful sound may produce stronger responses. Your name can sometimes attract attention even during sleep. This suggests that the brain does not completely disconnect from the environment. Instead, it filters. It decides what deserves attention. This filtering is one reason you can sleep through ordinary background noise, but wake instantly when something feels important. Your sleeping brain is still listening. It is simply listening differently. Perhaps this is one of the most comforting aspects of sleep. Even when your conscious mind lets go, the brain continues monitoring the world. You do not need to remain consciously alert. Your nervous system can handle the background work, and this allows you to surrender to rest. There is something deeply ancient about that surrender. Every night, you temporarily give up conscious control. You trust your body. You trust your surroundings. You allow your awareness to disappear for a while, and then, hours later, you return. You may not remember the transition. You may simply notice that morning has arrived. But between those two moments, an enormous amount of biological activity has occurred. Your brain has cycled through stages. Your body has changed temperature. Your hormones have shifted. Your memories have been processed. Your immune system has continued its work. Your muscles have remained mostly still. Your heart has kept beating. Your lungs have kept breathing. And time has quietly passed. Now, perhaps, your own breathing has become slower. Maybe the room feels darker. Maybe the words are becoming harder to follow. That is perfectly fine. You do not have to reach the end. There is no need to keep your attention here. Let the ideas become background noise. You can forget the details. You can allow the sentences to blend together. The night does not require your concentration. It only requires that you rest. So let your shoulders sink a little deeper. Let your hands become still. Let your face soften. There is nowhere else you need to be. The day is finished. The future can wait. And somewhere inside your brain, the next quiet wave of sleep may already be approaching. Perhaps you will dream. Perhaps you will not remember dreaming. Perhaps you will wake briefly and return to sleep. Perhaps you will simply disappear into several hours of quiet darkness. Whatever happens, your biology will continue its work. The brain will continue its rhythms. The heart will continue its gentle beat. The lungs will continue their quiet movement. And the night will continue moving forward. Slowly, steadily, without asking anything from you. You can simply rest. And as the final thoughts of the day become softer, remember one simple idea. Sleep is not time lost. It is time during which your body and brain are doing work you cannot perform while fully awake. The maintenance is happening. The memories are being organized. The rhythms are shifting. The systems are recovering. And you do not need to supervise any of it. You only need to let yourself be still. So if you are still awake, breathe gently. If your thoughts wander, let them wander. If you begin dreaming, let the dream arrive. And if you fall asleep before the next words reach you, then let them disappear into the darkness. The night belongs to you now. Rest deeply, sleep gently, and let the quiet science of sleep carry you onward. The night continues quietly, and while you rest, your body is moving through a sequence that has been repeated countless times throughout human history. Sleep may feel like one long, peaceful stretch of unconsciousness, but beneath that feeling, your brain is constantly changing states. The deeper we look, the more remarkable sleep becomes. Your brain does not simply move from awake to asleep and remain there. Instead, it moves through carefully organized patterns, each with its own characteristics and biological purpose. And every night, these patterns repeat in a slightly different way. One of the most interesting things scientists have discovered is that sleep is surprisingly structured. When researchers record brain activity during sleep, they can see recognizable patterns. Electrical activity changes. Eye movements change. Muscle activity changes. Breathing changes. Heart rate changes. And the timing of these changes provides a window into what the sleeping brain is doing. This is why scientists can identify different sleep stages using a technique called polysomnography. During a sleep study, sensors can measure brain waves, eye movements, muscle activity, heart rhythm, breathing, and other signals. The person simply sleeps. Meanwhile, the equipment records the invisible architecture of the night. It is almost like listening to an orchestra without hearing the music directly. Scientists cannot simply ask the sleeping brain what it is doing. Instead, they observe the patterns produced by the brain and body. One of the most important measurements is the electroencephalogram, commonly known as an EEG. Electrodes placed on the scalp detect electrical activity generated by large groups of neurons. The resulting patterns can reveal whether a person is awake, in light sleep, deep sleep, or REM sleep. When you are awake and alert, the brain can produce relatively fast and varied electrical activity. As you become drowsy, the pattern begins to change. As sleep deepens, slower rhythms become more prominent. During deep sleep, large slow waves dominate. And during REM sleep, the brain can once again display relatively active patterns. This makes the sleeping brain surprisingly visible. Even though your eyes are closed and your body is mostly still, your brain is continuously producing measurable activity. Sleep researchers can almost watch the night unfold through electrical signals. Another fascinating feature of deep sleep is that slow waves are not necessarily uniform across the entire brain. Different areas can show different levels of slow wave activity. This means that sleep can have a local component. If a particular region of the brain has been heavily used during the day, its local sleep activity can sometimes increase afterward. In a sense, the brain may keep track of which areas have been working hardest. This supports the idea that sleep is not only controlled globally. Individual regions may have their own local needs for recovery. Imagine spending the day learning a complicated skill. Certain brain networks become heavily involved. Later, during sleep, those regions may show changes reflecting their earlier activity. Your brain may therefore carry traces of the day's work into the night. Even when you are unconscious, the history of your waking experiences can influence what happens next. This is one reason sleep is sometimes described as an active biological process rather than a passive state. Another important concept is sleep homeostasis. Your body tries to maintain a balance between time awake and time asleep. If you remain awake longer than usual, the pressure to sleep increases. If you sleep longer after being deprived, your body may reduce the amount of sleep pressure that has accumulated. This is one reason people can sometimes sleep unusually long after several nights of insufficient sleep. The body is attempting to recover. However, recovery sleep does not always perfectly erase every consequence of chronic sleep deprivation. A few long nights may help, but consistently adequate sleep is generally more reliable than repeatedly accumulating a large sleep debt and attempting to repay it later. Your body prefers regularity. It likes predictable rhythms. This is especially true of the circadian system. The circadian clock does not simply determine when you sleep. It influences many physiological processes throughout the day: body temperature, hormone release, metabolism, alertness, blood pressure, immune activity, and digestion. All of these processes can follow daily rhythms. Sleep is therefore part of a much larger biological timetable. Your body is constantly preparing for what comes next. During the morning, certain systems become more active. During the evening, others become quieter. During the night, repair and maintenance processes become more prominent. The transition is gradual. Your body does not flip from daytime mode to nighttime mode like a light switch. Instead, thousands of processes shift at different speeds. This is why changing your schedule can sometimes feel uncomfortable. Your conscious mind may decide that bedtime has changed. Your biology may take longer to agree. Another fascinating part of sleep is its connection with body temperature. Core temperature tends to reach its lowest point during the biological night. This decline helps support sleep. Then, toward morning, temperature begins to rise again. The increase helps prepare the body for wakefulness. Temperature is therefore not simply a passive consequence of sleep. It is part of the timing system. This is why the environment can matter. A bedroom that is too warm may interfere with the natural cooling process. A comfortably cool environment can support the body's transition into sleep. The relationship between temperature and sleep also explains why people often feel sleepy when lying somewhere warm and comfortable. The combination of warmth at the skin and a gradual decline in internal temperature can create a powerful signal for relaxation. Sleep is also closely connected with the autonomic nervous system. This system controls many functions you do not consciously direct: heart rate, blood vessel activity, digestion, sweating, breathing patterns. During sleep, the balance between different branches of the autonomic nervous system changes. During deep non-REM sleep, the body generally shifts toward a calmer physiological state. Heart rate decreases. Blood pressure tends to fall. The body becomes less responsive to the outside world. This can be considered a period of reduced physiological demand. REM sleep is different. Autonomic activity becomes more variable. Heart rate and breathing may fluctuate. This contrast between deep non-REM sleep and REM sleep demonstrates again that sleep is not one uniform state. It is a series of distinct biological environments. Another surprising fact is that your brain can sometimes create highly realistic sensations during dreams. You can dream that you are falling, flying, running, swimming, speaking, hearing music, feeling warmth, feeling fear, feeling happiness, even experiencing pain. Dreams can combine multiple senses into a coherent internal experience. This happens because the brain is capable of constructing perception internally. Normally, perception begins with signals arriving from the outside world. Light enters the eyes. Sound waves reach the ears. Pressure activates the skin. Chemical molecules activate smell and taste receptors. The brain processes these signals and creates your conscious experience. During dreaming, many of the signals begin internally. The brain creates patterns that resemble perception. The result can feel remarkably real. This is one reason dreams can be emotionally powerful. The brain does not necessarily label every dream experience as imaginary while you are inside it. You simply experience it. You are there. Only after waking may you realize how strange it was. Sometimes, you may even carry the emotional feeling of a dream into the morning. A frightening dream can leave you anxious for a few moments. A pleasant dream can leave you feeling peaceful. A strange dream can stay in your mind for hours. This demonstrates that emotional systems can remain influenced by experiences generated entirely within the sleeping brain. Another fascinating phenomenon is lucid dreaming. In a lucid dream, the dreamer becomes aware that they are dreaming while the dream is still occurring. Some people report being able to influence parts of the dream. They may change locations, attempt to fly, speak with dream characters, or simply observe the dream while knowing it is not waking reality. Lucid dreaming has been studied scientifically. Researchers have found ways to identify certain lucid dreams through prearranged eye movements during REM sleep. Because most of the body is temporarily paralyzed during REM, deliberate eye movements can sometimes provide a signal that the dreamer has become aware within the dream. This is a remarkable example of communication between a dreaming brain and the outside world. The person is asleep. The dream is occurring. Yet a planned signal can sometimes be produced. It reminds us that sleep is not a simple state of complete disconnection. there can be layers of awareness within it. Some people also experience sleep paralysis. During sleep paralysis, a person becomes conscious while the muscle inhibition associated with REM sleep is still present. The result can be frightening. They may feel awake but unable to move. Some people experience vivid hallucinations during the episode. They may sense a presence in the room, see shapes, hear sounds, or feel pressure. These experiences can seem supernatural because they occur during a strange overlap between dreaming and waking. But sleep science provides a biological explanation. The brain has awakened. The body has not fully transitioned out of REM-related muscle inhibition. Dream imagery may also continue briefly. The result is an unusual hybrid state. Sleep paralysis can happen to healthy people and is often temporary. It is another example of how the boundaries between sleep and wakefulness are more flexible than they seem. Sometimes the brain does not switch states all at once. Different systems transition at slightly different times. Awareness may return before movement. Movement may return before complete alertness. Dream imagery may continue briefly after waking. This gradual transition is one of the reasons unusual sleep experiences can occur. Another common experience occurs during the transition into sleep. Some people hear a sudden loud sound even though nothing outside made the noise. This phenomenon is known as exploding head syndrome. Despite its alarming name, it is generally considered a benign sleep-related sensory phenomenon. A person may hear a bang, crash, snap, or electrical sound while falling asleep or waking. There is no actual explosion. The experience is generated internally. Again, the brain is crossing a boundary between waking perception and sleep. During these transitions, sensory processing can behave in unusual ways. The brain may generate experiences that feel external even though they originate internally. This shows just how powerful the brain's perceptual machinery can be. It does not always require the outside world to produce a convincing experience. Your brain can create one on its own. Sleep also influences how we experience pain. Poor sleep can increase sensitivity to pain in some circumstances. Pain, in turn, can interfere with sleep. This creates another feedback loop. Pain makes sleep harder. Poor sleep can make pain feel worse. The resulting fatigue can increase stress. Stress can further interfere with sleep. The body is interconnected. A disturbance in one system can ripple into another. This is why sleep is increasingly considered part of overall health rather than a separate issue. Sleep also interacts with cardiovascular function. During healthy non-REM sleep, heart rate and blood pressure generally decrease compared with waking levels. This provides the cardiovascular system with a period of reduced demand. The body is not running at full daytime intensity. It is entering a quieter physiological mode. This nightly reduction in cardiovascular activity is one reason sleep is considered important for cardiovascular health. The sleeping body is not simply resting muscles. The entire cardiovascular system experiences a different environment. Your blood vessels, your heart, your autonomic nervous system, your hormonal systems, all participate in the nightly transition. Sleep also interacts with metabolism. Your body continues using energy while asleep. Your cells require fuel. Your brain continues consuming glucose and oxygen. Your heart continues pumping blood. Your lungs continue exchanging gases. But metabolism is regulated differently during sleep. Hormones involved in appetite and energy balance change. Insulin sensitivity can be influenced by sleep patterns. Glucose regulation can also be affected by insufficient sleep. This is another reason chronic sleep disruption can influence broader health. The body does not separate sleep from metabolism. They are deeply connected. Sleep also interacts with growth and development. Children generally require more sleep than adults. Their bodies and brains are developing rapidly. During childhood, sleep supports processes related to learning, growth, emotional development, and physical restoration. Infants sleep for much of the day. Their sleep is also highly fragmented. They do not necessarily sleep in the long, continuous blocks that adults prefer. This reflects their developmental stage. Newborn sleep is different because their circadian systems are still maturing. They do not begin life with a fully developed 24-hour sleep-wake rhythm. Instead, their biological timing gradually becomes more organized. Light exposure, feeding, social interaction, and development all contribute to this process. Over time, the infant's sleep becomes more consolidated. This transformation is a beautiful example of how biological rhythms develop. Adolescence brings another major change. Teenagers often experience a shift toward later sleep timing. This is partly biological. The circadian system tends to delay. Melatonin may be released later in the evening. As a result, teenagers may naturally feel sleepy later at night and want to wake later in the morning. This can conflict with early school schedules. The problem is not necessarily that teenagers are lazy. Their biology may genuinely favor a later schedule. This mismatch between biological timing and social schedules is sometimes called social jet lag. A person may sleep according to one schedule on weekdays and another on weekends. The difference can create a pattern resembling repeated small time zone shifts. Adults can experience this too. Working late, sleeping late on weekends, waking early for work, then trying to compensate by sleeping longer. The biological clock is constantly adjusting to these changes. Consistency can make its job easier. Sleep timing is therefore important alongside sleep duration. Two people can both sleep 7 hours, but experience those 7 hours at very different biological times. The body cares about timing. This is why shift work can be particularly challenging. A person may need to sleep when the circadian system is promoting wakefulness. They may then need to work when the body is biologically prepared for sleep. This conflict can make sleep shorter or more fragmented. The human body is adaptable, but it remains strongly influenced by the 24-hour cycle of light and darkness. Another interesting fact is that humans are not the only animals with circadian rhythms. Nearly every organism studied has some form of biological timing. Plants have daily cycles. Animals have daily cycles. Even microorganisms can show rhythmic biological behavior. The 24-hour rhythm is deeply embedded in life on Earth. This makes sense because the planet itself rotates every day. Life evolved under a repeating pattern. Light arrives, darkness arrives, temperature changes, food availability changes, predator activity changes, and organisms adapt. Sleep is one expression of this ancient biological rhythm. Your body is still carrying the memory of Earth's rotation. Every evening, your internal systems begin preparing for darkness. Every morning, they prepare for light. And even if you live inside a brightly lit building, the basic rhythm remains. Another fascinating aspect is how darkness influences melatonin. Melatonin production generally increases when the environment becomes darker. Bright light can suppress it. This is why keeping a bedroom dark can support normal nighttime signaling. The brain receives a clearer message. It is nighttime. You can rest. This does not mean that every tiny amount of light will prevent sleep. Human biology is not that fragile, but the overall lighting environment can matter. A brightly illuminated room sends a very different signal from a completely dark room. Your brain notices the difference. Your eyes are not merely cameras. They are also biological sensors that help regulate your internal clock. Specialized retinal cells respond strongly to light and send timing information to the brain. These cells are particularly sensitive to the blue portion of the light spectrum. Their job is not primarily to help you see. Their role includes helping synchronize circadian rhythms. This is one reason the eyes influence sleep even when you are not consciously paying attention to what you see. Light enters. Signals travel. The biological clock responds. The body's timing system adjusts, all without conscious effort. This is another example of how much of your physiology operates beneath awareness. Your conscious mind does not have to know that light entered your eyes. The biological clock knows. Your conscious mind does not have to know that adenosine has accumulated. The sleep system knows. You do not have to calculate your body temperature. Your nervous system monitors it. Sleep emerges from the interaction of these countless signals. It is a system rather than a single switch. And perhaps that is why sleep can sometimes be difficult to understand. There is no single sleep center doing everything. Many regions of the brain communicate to control arousal, circadian timing, hormones, temperature, and sleep stages. The hypothalamus plays a major role. The brainstem plays important roles. The thalamus contributes to sensory processing. The cortex changes its activity. The hippocampus participates in memory. The pineal gland produces melatonin, and many other structures contribute. Sleep is therefore a whole brain and whole body phenomenon. The more scientists study it, the more interconnected it appears. This is why one simple question like, "Why do we sleep?" has no simple answer. Sleep may perform many functions simultaneously. There may not be one single purpose. Instead, sleep could be a state that allows numerous processes to happen efficiently at the same time. Memory processing, metabolic regulation, immune function, emotional processing, cellular maintenance, synaptic regulation, hormonal coordination, energy management, and much more. The mystery is not necessarily that sleep has no purpose. The mystery is that it may have so many. And perhaps that is why sleep is so deeply conserved across evolution. The costs of sleeping are enormous. You become less responsive. You cannot eat. You cannot actively search for food. You cannot fully monitor predators. You cannot perform most daytime activities. Yet nearly every complex animal still needs some form of sleep. The benefits must therefore be powerful. Sleep is worth the vulnerability. Sleep is worth the time. Sleep is worth surrendering consciousness. That alone tells us something extraordinary. Your body values sleep enough to make you do it every night. And as you lie quietly now, perhaps your body is beginning to claim that time again. The day is fading. The mind is slowing. The room is quiet. And the boundary between thinking and dreaming is becoming thinner. You do not have to force the transition. Let it happen naturally. Maybe you can feel the weight of your body against the bed. Maybe your breathing has become softer. Maybe your thoughts are less organized. Maybe you have already forgotten parts of what you heard. That is exactly what we want. There is nothing you need to retain. Let the facts pass through your mind. Let the sentences become background sounds. Let the night become more important than the story. Your brain has been awake long enough. It has worked, learned, remembered, reacted, planned, and worried. Now it can change modes. The quiet systems can take over. Slow waves can begin moving across the brain. The heart can settle. The muscles can remain still. The senses can become distant. And consciousness can gradually loosen its grip on the outside world. You do not have to hold on to today. You can release it. Tomorrow will arrive whether you think about it or not. There is no need to prepare for it right now. For this moment, there is only darkness, only quiet, only breath, and the gentle rhythm of sleep approaching. So if you are still listening, stay comfortable. If you are already drifting, let yourself drift farther. The next words do not matter. The next fact does not matter. The next thought does not matter. You can let them disappear. Your body knows the way. Your brain knows the rhythm. And the night is long enough for you to rest. Sleep gently, breathe slowly, and allow the quiet science of sleep to continue around you. As the night becomes deeper, we can begin to explore one of the most fascinating parts of sleep, the way it quietly changes almost every system inside you. From the rhythm of your heart to the organization of your memories, sleep is constantly working in the background. You may feel as though you are doing nothing, but biologically, you are far from inactive. Your body is simply working in a different way. One of the most important things sleep does is provide a period in which the brain can coordinate processes that are difficult to perform during full wakefulness. During the day, your attention is constantly being pulled outward. There are conversations, messages, traffic, work, school, music, people, notifications, decisions. Even when you are sitting quietly, your brain is processing information. Sleep provides a different environment. The outside world becomes quieter. Sensory input decreases. Movement decreases. Conscious decision-making largely stops. And the brain can devote itself to internal organization. This is one reason sleep is sometimes compared with maintenance. A building that operates 24 hours a day still needs periods when certain systems can be inspected. Your brain is similar. It has enormous numbers of connections. It processes an enormous amount of information. And every day, those connections are modified by experience. Sleep provides time for the system to stabilize. One fascinating example involves learning. When you learn something new, the memory may initially depend heavily on the hippocampus. Later, during sleep, the brain can gradually integrate aspects of that memory into broader cortical networks. This process is not instantaneous. It may continue across multiple nights. This means that remembering something tomorrow is not necessarily the end of the story. Your brain may continue reorganizing the memory for days, weeks, or longer. Some memories become stronger with time. Others become less precise. And interestingly, memories are not always stored exactly as they originally occurred. Every time you remember something, the memory can potentially be modified. Sleep may influence that process. The sleeping brain may strengthen the emotional meaning of an experience while allowing certain details to fade. This can be useful. Imagine remembering a childhood trip. You may remember that the trip was joyful. You may remember the general location. You may remember certain people, but you probably do not remember every single minute. The brain preserves the important structure. The unnecessary details gradually disappear. This is one reason forgetting is not necessarily a failure of memory. Forgetting can be part of memory management. Your brain has limited resources. It cannot preserve everything with equal precision. Sleep may help determine which information deserves continued storage. Another interesting feature is that sleep can help stabilize newly learned motor skills. Suppose you learn a new sequence of movements. Perhaps you practice typing, play a musical instrument, learn a dance, practice a tennis serve, or work on a complicated physical technique. During practice, your performance may be inconsistent. You make mistakes. You pause. You forget the sequence. Then you sleep. The following day, the movement may feel smoother. This improvement can happen even without additional practice. The brain has continued processing the skill. This is sometimes called offline learning. The body was still, but the nervous system was not finished. It was refining the pattern. This is one reason rest days can be valuable in training. The nervous system needs time to integrate practice. Muscles need recovery, and the brain needs time to organize movement patterns. Sleep therefore contributes to physical learning just as much as mental learning. Another fascinating aspect of sleep is how it influences attention. When you are rested, the brain can sustain attention for longer periods. You can follow a conversation, read a paragraph, drive a car, work through a problem, monitor your surroundings. When you are sleep deprived, attention becomes more fragile. Your mind may wander. You may reread the same sentence. You may miss details. You may find yourself staring at something without fully processing it. This is not simply a lack of motivation. The brain's ability to maintain attention is being affected. One particularly dangerous consequence is the appearance of microsleeps. A microsleep is a very brief episode in which the brain partially enters sleep-like activity for seconds or even less. The person may appear awake. Their eyes may remain open, but their brain is temporarily less responsive. Microsleeps are especially dangerous while driving or operating machinery. A few seconds of reduced awareness can be enough to cause a serious accident. This is one reason tired driving is such an important safety issue. Sleep deprivation can impair reaction time in ways that resemble other forms of impairment. The problem is that people often underestimate how sleepy they are. They may believe they can push through. They may turn up the music, open the window, drink coffee, but none of these methods replaces sleep. The brain eventually needs the real thing. Another remarkable feature of sleep deprivation is its effect on decision-making. When tired, people may become more impulsive. They may have difficulty evaluating risks. They may be more emotionally reactive, and they may choose immediate rewards over long-term benefits. This makes sense from an evolutionary perspective. A tired brain may be searching for energy and efficiency, but in the modern world, these changes can influence work, relationships, driving, finances, and countless other decisions. Sleep therefore affects more than how awake you feel. It affects how you behave. Mood is another major area. A single poor night can make you irritable. Several poor nights can increase emotional instability. Chronic sleep disruption can be associated with greater vulnerability to anxiety and depression. The relationship is complicated because mental health and sleep influence each other. Emotional distress can interfere with sleep. Poor sleep can worsen emotional distress. This creates feedback loops. The brain and body rarely operate in isolation. Sleep is part of the larger emotional system. When you sleep well, emotional experiences can often be processed more effectively. When you sleep poorly, the brain's response to negative information may become stronger. This can make ordinary problems feel more threatening. A small inconvenience can suddenly seem enormous at 2 in the morning. Then, after sleep, the same problem may appear much smaller. The situation did not necessarily change. Your brain did. This is one of the simplest ways to understand the relationship between sleep and emotional regulation. A tired brain can interpret the world differently. A rested brain may have more emotional distance. Sleep also influences social behavior. When people are sleep deprived, they may become less patient. They may interpret facial expressions differently. They may find it harder to understand social cues. They may be less motivated to interact with others. In this way, sleep can influence relationships. You may think of sleep as something you do alone, but its consequences extend into your interactions with other people. Being rested can make it easier to listen, to empathize, to remain calm, to respond rather than react. Sleep is therefore indirectly connected to social connection. Another fascinating discovery involves the way sleep deprivation can change the brain's reward system. When you are tired, highly rewarding stimuli may become more attractive. Sweet foods, rich foods, entertainment, social media, other immediate rewards. The brain may be seeking stimulation because energy and alertness are low. This can create a difficult cycle. You are tired. You seek stimulation. The stimulation delays sleep. You sleep less. Then you need even more stimulation the next day. Modern technology can make this cycle especially easy. A phone can provide endless novelty. Every swipe produces something new. Every notification offers a tiny burst of information. The brain is naturally attracted to novelty, but bedtime is a period when reducing novelty can be useful. The brain needs fewer reasons to remain alert. This is why a quiet, predictable environment can be so powerful. The goal is not to make your mind completely empty. That is unrealistic. The goal is to stop feeding it new material. No new messages. No new arguments. No endless scrolling. No complicated decisions. Just quiet. Eventually, the brain begins to run out of reasons to stay awake. Another interesting fact is that sleep can influence how you perceive time during the day. After a good night's sleep, hours can feel different from when you are exhausted. Fatigue can make time feel slower. Waiting can feel longer. Tasks can feel more difficult. A rested mind can move through the same activities with greater ease. This demonstrates that sleep changes subjective experience. It does not simply change physical energy. It changes how the world feels. Even colors, sounds, and emotional experiences can seem different when you are exhausted. Your brain is responsible for constructing your perception of reality. Sleep affects the machinery involved in that construction. This is why fatigue can make the world seem slightly unreal. You may feel detached, foggy, slow, or as though you are watching the day through a layer of mist. After adequate sleep, the same world can suddenly feel clearer. Nothing outside you necessarily changed. Your brain's processing did. Sleep also influences language. When tired, finding the right word can become harder. You may know exactly what you want to say, but struggle to retrieve the word. You may make more mistakes while speaking or writing. You may have difficulty following complicated explanations. This happens because language requires attention, memory, and rapid information processing. All of these depend on a well-functioning brain. Sleep supports them. The same applies to mathematics and reasoning. Complex calculations become harder when attention is unstable. Working memory becomes less reliable. You may lose track of intermediate steps. A problem that normally feels easy suddenly feels confusing. Again, the issue is not intelligence. It is cognitive resources. The tired brain simply has fewer resources available for sustained processing. This is why sleep is so important for students. Studying longer is not always better if the extra hours are purchased with severe sleep loss. The brain needs time to consolidate what was learned. Sometimes closing the book and sleeping is a better learning strategy than continuing to stare at the page. This can feel counterintuitive, but the brain does not learn only while you are consciously studying. Learning continues after the lights go out. Sleep is part of the educational process. Another fascinating area is creativity. People often report unusual ideas after waking from sleep. One possible reason is that sleep changes the relationships between memories. The brain can combine pieces of information in ways that may be less constrained than during focused waking attention. Dreams demonstrate this ability. A familiar person may appear in an unfamiliar place. Two memories may merge. A normal object may become something completely different. The dream brain is remarkably flexible. This does not mean every dream contains a hidden message. Dreams are not necessarily predictions. They may simply reflect the brain's tendency to generate patterns from memory, emotion, and spontaneous activity. Yet that spontaneous recombination can sometimes produce interesting insights. The sleeping brain is not bound by the same rules as waking thought, and this may contribute to creativity. Sleep also influences the immune response through complex hormonal and neural pathways. Certain immune cells and signaling molecules follow daily rhythms. Your body does not maintain exactly the same immune state throughout 24 hours. The immune system changes with the biological clock. Sleep is integrated into this rhythm. This helps explain why consistent sleep is associated with healthier immune regulation. It also explains why illness can change sleep. When the immune system becomes active, signals can reach the brain and influence behavior. Fatigue, sleepiness, reduced activity, changes in appetite. These responses may help conserve energy during illness. The body essentially says, slow down, stay still, recover. This instinct is ancient. Animals often become less active when sick. They seek sheltered places. They rest. They sleep. Humans sometimes try to fight through illness instead. But biologically, the desire to rest is meaningful. Your body may be asking for time. Sleep also plays a role in tissue repair. During deep sleep, growth hormone secretion increases. Growth hormone supports many processes involving growth, tissue maintenance, and metabolism. This is particularly important during childhood and adolescence. But adults also produce growth hormone. The amount and timing change with age. Deep sleep, therefore, remains physiologically meaningful throughout life. Your body is constantly repairing small amounts of everyday damage. Cells are replaced. Proteins are produced. Tissues are maintained. Metabolic waste is processed. Sleep provides an environment where many of these processes can proceed efficiently. This is why chronic sleep loss can have consequences far beyond tiredness. The body depends on sleep for long-term maintenance. Another fascinating connection is between sleep and blood sugar regulation. Sleep loss can reduce insulin sensitivity in some circumstances. This means the body may need more insulin to achieve the same glucose-lowering effect. Repeated disruption can place additional stress on metabolic regulation. Again, sleep is not isolated. The amount and quality of sleep can influence how your body handles food. This is one reason sleep is often discussed alongside nutrition and exercise when considering metabolic health. Your body is a network. Food provides energy. Exercise changes energy demand. Sleep helps regulate recovery and metabolism. The three interact continuously. Another interesting fact is that sleep affects hormones involved in hunger. Leptin and ghrelin are often discussed in relation to appetite. Sleep deprivation can alter their regulation. Although the relationship is more complex than simply saying one hormone rises and another falls. The broader point is that insufficient sleep can influence appetite signals. This may make it harder to regulate food intake naturally. When people are exhausted, cravings can feel stronger. The brain's reward system can become more responsive to high-calorie foods. And fatigue reduces the energy available for deliberate decision-making. This is another example of biology influencing behavior. Sleep is therefore part of weight regulation in ways that many people underestimate. Another remarkable feature is how quickly sleep loss can affect mood. You do not necessarily need weeks of poor sleep before noticing a change. A single night of restricted sleep can alter emotional responses. The brain may become more reactive to negative stimuli. Positive experiences may feel less rewarding, and ordinary frustrations may feel more intense. This is one reason sleep can be considered emotional preparation. Each night gives the brain an opportunity to reset its response systems. The morning version of you may not feel exactly like the nighttime version. The difference may partly come from sleep. The brain has processed another night of experiences. The body has restored another layer of balance. And emotional intensity can shift. This does not mean sleep solves emotional problems, but it can change the brain's ability to handle them. Another beautiful feature of sleep is that it creates separation from the events of the day. During waking hours, problems feel immediate. A message arrives. A deadline approaches. A disagreement occurs. You cannot simply turn away from these things. At night, the brain creates distance. For several hours, the outside world becomes less important. The separation can be psychologically valuable. Even if the problem remains tomorrow, your brain has had time away from it. This is one reason people sometimes wake feeling more capable of handling something that seemed overwhelming the night before. Sleep creates perspective. Not always, not perfectly, but sometimes enough to make a difference. There is a reason humans have been saying "sleep on it" for generations. The phrase reflects something deeply intuitive about the brain. Time plus sleep can change how information feels. A decision that seems urgent at midnight may feel less urgent in the morning. A conflict may appear more complicated at night than it does after rest. A difficult task may feel more manageable. Again, the external situation may not have changed. The brain has. And now, as you listen in the quiet of the night, perhaps your own brain is beginning to make that same transition. The world outside may still be moving. Cars may pass. Lights may remain on. People may still be awake. But you do not have to participate. For now, you can remain here. Quiet. Still. Comfortable. Your breathing does not need to be controlled. Let it find its own rhythm. Your body knows how to breathe during sleep. Your heart knows how to continue beating. Your brain knows how to transition between states. You do not need to supervise any of it. This is one of the greatest gifts of biology. Most of the work does not require conscious attention. You can simply let go. Perhaps your thoughts are already becoming less organized. Maybe you started following one idea and suddenly found yourself thinking about something completely different. That is normal. The sleeping brain is approaching. Attention becomes softer. The boundaries between thoughts become less distinct. You may hear a sentence and forget it almost immediately. That is okay. You do not need to remember. The goal is not knowledge anymore. The goal is rest. So let the facts become background. Let the story become quieter. Let the words move past you. And if you find yourself drifting somewhere between wakefulness and dreaming, you can simply remain there. There is nothing to accomplish. No need to check the time. No need to calculate how long you have been awake. No need to wonder whether you are asleep yet. Sleep does not need to be measured. Let it happen. Your body has been preparing for this moment since the beginning of the evening. Sleep pressure has accumulated. Your circadian rhythm has shifted. Your body temperature has changed. Your brain has become less responsive to the outside world. And now the pieces are coming together. The night is becoming deeper. The room is becoming quieter. Your thoughts can become slower. Your muscles can become heavier. Your breathing can become softer. And the world can gradually disappear. Soon, perhaps, the next sentence will no longer matter. Perhaps you will hear only fragments. Perhaps the voice will become part of the background. Perhaps you will simply drift away. That is perfectly fine. Sleep is already waiting, and you do not have to chase it. You only have to stop chasing everything else. Let tomorrow remain tomorrow. Let yesterday remain yesterday. For this moment, there is only now. A quiet room, a resting body, a slowing mind, and the gentle rhythm of the night. So breathe softly, relax completely, and allow yourself to become less aware of everything around you. The brain can continue its quiet work. The body can continue its quiet maintenance. And you can simply rest. Because sometimes the most productive thing the human body can do is nothing at all. And perhaps, as the final thoughts of this section fade into the darkness, you can let your own thoughts fade with them. There is no need to stay awake for the next fact. There is no need to finish the story. There is no need to reach the end. The night is already carrying you forward. Slowly, quietly, naturally, towards sleep. As the night becomes quieter still, there is another layer of sleep to explore. By now, you may already be noticing how strange it is that something so ordinary can contain so much complexity. Every night, you close your eyes. Every night, your brain changes. And every morning, you return. Yet between those two moments, your body performs an enormous amount of invisible work. Sleep is one of the oldest biological rhythms on Earth. Long before humans existed, living organisms were already responding to cycles of light and darkness. The planet rotated. Sunlight appeared. Darkness returned. Temperatures changed. Food became available at different times. Predators became active, and organisms adapted their behavior to these repeating patterns. Human sleep is one expression of that ancient rhythm. Even today, your body still carries an internal expectation that darkness should be associated with rest. This expectation is encoded in your circadian system. The word circadian comes from Latin words meaning approximately around a day. That description is remarkably appropriate. Your biological clock does not run at exactly 24 hours under every circumstance. Without external cues, the internal rhythm can drift slightly, but environmental signals repeatedly reset it. The strongest signal is light. Morning light tells your biological clock that a new day has begun. Evening darkness tells it that biological night is approaching. This daily synchronization keeps your internal rhythm aligned with the planet. It is an extraordinary example of biology matching astronomy. Your sleep schedule is ultimately connected to the rotation of Earth. Every time the planet turns, your internal clock receives another opportunity to synchronize. And yet the body does not depend on light alone. Food timing can also provide signals. Physical activity can influence rhythms. Social interaction can influence timing. Temperature can provide information. Even the timing of daily routines can become biological cues. The body is constantly collecting information about what time it believes it is. This is why irregular schedules can sometimes feel confusing. The clock on the wall may say one thing. Your biology may say something else. Imagine waking at noon one day, sleeping at 3 in the morning, then waking at 6 the next day. Your conscious mind can understand the schedule. Your biological clock has a harder time. It needs repeated signals before the rhythm becomes stable again. This is why consistency can be so helpful for sleep. Your brain learns patterns, and when the pattern repeats, the body begins anticipating it. If you usually become sleepy around the same time, your body may begin preparing for sleep before you consciously decide to go to bed. Hormones shift, temperature changes, alertness decreases. The brain begins moving toward nighttime physiology. It is as though the body knows the schedule before you do. One of the most important nighttime signals is melatonin. Melatonin is often described as the sleep hormone, but that description is incomplete. Melatonin does not simply make you unconscious. Instead, it helps communicate the timing of biological night. Its levels generally rise in dim light and darkness. This signal helps coordinate many physiological processes with the nighttime period. Melatonin is therefore more like a biological message. Night has arrived. Prepare accordingly. The timing of melatonin production varies between individuals. Some people naturally produce it earlier, others later. This contributes to differences in sleep timing. It also helps explain why forcing every person into the exact same bedtime can be unrealistic. Biology contains variation. Some people naturally feel sleepy early in the evening. Others become alert later. These differences are partly influenced by genetics. Your sleep preference is not entirely a matter of discipline. Your biological clock has a personality of its own. This is sometimes described as your chronotype. A chronotype refers broadly to an individual's preferred timing of sleep and activity. Some people are naturally early, others naturally late. Many fall somewhere in between. Chronotype can change with age. Children often wake early. Adolescents tend to shift later. Many adults gradually move earlier again as they age. The biological clock is therefore not fixed throughout life. It develops and changes. This is one reason sleep patterns during childhood can look completely different from those during adulthood. Newborns do not immediately have the mature circadian rhythm of an adult. Their internal clocks are still developing. They sleep in multiple shorter periods. Over time, their rhythms become increasingly organized around the 24-hour day. This process takes months, and it demonstrates that circadian timing is not simply something we are born knowing. It develops through biology and environmental signals. Sleep itself also changes dramatically during infancy. Newborns spend a large proportion of their time asleep, but their sleep architecture is different from adult sleep. They enter REM-like sleep more readily. Their cycles are shorter. Their awakenings are frequent. Their nervous systems are still developing rapidly. Sleep is therefore particularly important during early life. The developing brain is building connections at an extraordinary rate. Experience and sleep interact. New sensory information arrives during waking. The brain processes and organizes it during both waking and sleeping states. Sleep may help shape the developing nervous system. This is one reason infants require so much of it. Their brains have an enormous amount of construction work underway. Children continue to require more sleep than adults. Growth, learning, memory, emotional development, physical recovery, all depend on adequate rest. During adolescence, sleep needs remain high even as schedules often become more difficult. Teenagers may naturally feel sleepy later, while schools and jobs may require early mornings. This creates a biological conflict. The teenager may genuinely need more sleep, yet their circadian clock may encourage later sleep. This is one reason adolescents can appear sleepy in early morning hours. Their biology may simply not be fully prepared for waking. This is not an excuse for unhealthy habits. It is a reminder that sleep timing is influenced by biology. Adults experience their own challenges: work schedules, family responsibilities, travel, technology, stress. These can all interfere with sleep. The modern world often expects people to be productive at almost any hour. But the biological clock continues operating. You cannot completely eliminate circadian timing. You can shift it, you can adapt, but you cannot simply switch it off. This becomes especially obvious during long-distance travel. Crossing several time zones can produce jet lag because the external clock changes faster than the internal clock. You may arrive somewhere where it is morning, but your body believes it is still nighttime. You may feel sleepy when everyone else is awake, then become alert when everyone else is preparing for bed. The mismatch gradually decreases as your biological clock adjusts. Light exposure is one of the most powerful tools for shifting the clock. Morning light tends to move the circadian system in one direction. Evening light can move it in another. The exact response depends on timing. This is why the timing of light exposure matters. Light is not simply bright or dark. Its effect depends on when it reaches your eyes. Your biological clock has a response curve. Different times of day produce different shifts. Scientists study this phenomenon carefully because it can help explain jet lag, shift work, delayed sleep schedules, and other circadian disorders. It also demonstrates how precisely the body responds to the environment. Your eyes do much more than allow you to see the world. They help tell your brain what time of day it is. Specialized retinal cells detect light and communicate with the suprachiasmatic nucleus. The suprachiasmatic nucleus acts as a central circadian pacemaker. From there, timing information influences many parts of the body. It is almost like a conductor coordinating an enormous biological orchestra. Different organs have their own local clocks. The brain has a clock. The liver has a clock. The heart has rhythmic processes. Other tissues have their own molecular timing mechanisms. The central clock helps coordinate them. This means that your body contains many clocks rather than only one. They communicate with one another. When the system is aligned, physiology follows a coherent rhythm. When the clocks become misaligned, problems can occur. Food timing can influence some peripheral clocks. Light strongly influences the central clock. Sleep itself is another part of the overall rhythm. This complex network explains why the timing of behaviors can matter. Eating at unusual times, working through the night, sleeping during daylight. These can send conflicting signals to different biological systems. The human body can adapt, but adaptation takes time, and the biological system may never become perfectly identical to a natural daytime schedule. This is why shift workers can face unique sleep challenges. A person working overnight may try to sleep during daylight, but daylight is a strong wake signal. Noise may be higher, temperature may be different, family members may be awake. Social responsibilities may interrupt sleep. The result can be shorter or fragmented sleep. The body wants to sleep. The environment says it is daytime. This conflict can make sleep difficult. The same principle applies to people who regularly change their schedules. The body prefers predictable timing. Another fascinating feature of sleep is how hunger interacts with the circadian system. People often become hungry around habitual meal times. This is not simply because the stomach is empty. The brain learns patterns. If you regularly eat at a particular hour, metabolic systems can begin preparing before food arrives. Digestive enzymes, hormonal signals, metabolic activity. The body anticipates food. This demonstrates how much of physiology is predictive. The body does not simply react. It prepares. Sleep works similarly. As bedtime approaches, the body begins preparing for rest. You may become less alert. Your temperature falls. Melatonin rises. The brain shifts. Your body anticipates sleep. This predictive nature is one of the most elegant aspects of biology. Your body is constantly preparing for the next phase before it arrives. Sleep also changes breathing patterns. During non-REM sleep, breathing tends to become more regular. During REM sleep, breathing can become more variable. This difference reflects changes in the nervous system. Breathing is normally automatic, but it remains responsive to changes in carbon dioxide and oxygen. The brain continuously monitors the chemistry of the blood. If carbon dioxide rises, breathing can increase. This control system operates throughout sleep. You do not need to think about it. Your brainstem handles it automatically. The same is true for heart rate. You do not consciously command your heart to beat while sleeping. The autonomic nervous system maintains the rhythm. This is one of the reasons sleep is possible. You can release conscious control because automatic systems take over. The sleeping body is not helpless. It is highly regulated. Your brain is monitoring internal conditions constantly. Blood chemistry, temperature, pressure, hormones, oxygen, carbon dioxide, all are part of the body's background monitoring system. This internal monitoring continues even when conscious awareness disappears. Sleep therefore involves surrendering conscious control without surrendering biological control. The body remains vigilant. It simply operates without your attention. Another fascinating feature is the relationship between sleep and pain. The brain's interpretation of pain is not purely determined by physical injury. Context matters. Attention matters. Emotion matters. Stress matters. And sleep matters. When you are exhausted, the nervous system can become more sensitive to painful stimuli. At the same time, pain can fragment sleep. This creates a cycle that can be difficult to break. Better sleep can sometimes improve pain tolerance. Reduced pain can make sleep easier. The two systems influence each other. This is another example of how sleep affects the way the brain interprets signals from the body. The brain is not simply receiving information, it is interpreting it, and sleep can change that interpretation. The same principle applies to temperature. A room can feel unbearably hot when you are tired. A small discomfort can become very noticeable. When rested, the same environment may feel easier to tolerate. Fatigue changes sensory processing. It changes attention. It changes emotional response. It changes the brain's ability to filter information. This is why sleep deprivation can make ordinary sensations feel more intense. Another interesting phenomenon is the effect of sleep on reaction time. Your brain needs to detect a stimulus, interpret it, choose a response, and send signals to the muscles. This process happens extremely quickly when you are rested. When you are sleep deprived, every step can become slower. The delay may seem tiny, but when driving at highway speed, tiny delays matter. A car can travel a surprising distance in a single second. A moment of reduced attention can therefore become dangerous. This is why adequate sleep is not simply about feeling good. It is also about maintaining safe performance. The same applies to machinery, construction equipment, industrial systems, aircraft, medical environments. Any situation requiring sustained attention can be affected by fatigue. Sleep science therefore has consequences far beyond bedrooms. It affects transportation, healthcare, workplaces, education, sports, military operations, and public safety. Another fascinating area is memory under sleep deprivation. When people are severely sleep deprived, the brain can struggle to encode new memories. You may experience something, but later have difficulty remembering it. This is different from forgetting something you already knew. The problem may occur at the initial encoding stage. If attention is poor, information never gets properly registered. You cannot remember what the brain never encoded effectively. This explains why studying while extremely tired can be frustrating. You may read the same page repeatedly. The words are visible, but the information is not being efficiently incorporated into memory. Sleep restores the attention needed for effective learning. This creates a cycle. Good sleep improves attention. Attention improves learning. Learning creates information to consolidate. Sleep consolidates some of that information. Then better sleep supports the next day's learning. Sleep and learning therefore reinforce each other. Another fascinating fact is that sleep can influence language learning. When you learn new vocabulary, the brain forms new associations. Sleep can help stabilize these associations. Some studies suggest that exposure to newly learned information around sleep can influence memory, although deliberately playing information while asleep is not a magical shortcut to learning. The sleeping brain is selective. It is not simply recording every sound that reaches the ears. Still, the broader principle remains. Sleep helps the brain integrate newly acquired knowledge. This is why studying immediately before sleep can sometimes be useful. The information is fresh. Then the brain enters a state in which consolidation can occur. But the key is still learning first. Sleep cannot replace understanding. It can support what you have already practiced. Sleep also has an interesting relationship with music. You can fall asleep while listening to music. The brain continues processing some auditory information even while asleep. Familiar sounds may become part of the sleep environment. Soft, predictable sounds can sometimes be relaxing, but sudden or unpredictable sounds can cause arousal. This is why the type and volume of nighttime sound matter. A gentle, constant background can be very different from random notifications. One is predictable, the other demands attention. Your brain is constantly deciding whether a sound matters. This filtering continues during sleep. It is another example of the brain protecting rest while maintaining a basic level of environmental awareness. Perhaps the most comforting part of all this is that you do not have to consciously perform these functions. Your brain does them automatically. You can simply lie still. And while you do, millions of processes continue. Your body regulates temperature. Your brain shifts activity. Your heart changes rhythm. Your breathing adjusts. Your hormones follow their patterns. Your memories are processed. Your immune system remains active. The body is never truly off. It is simply quiet. And perhaps tonight, your own body is asking for that quiet. Maybe your muscles are beginning to feel heavier. Maybe your thoughts are slowing. Maybe you are losing track of the story. That is perfectly fine. You are not failing to listen. You are succeeding at resting. There is no requirement to stay awake until the end. In fact, if you have already drifted into sleep, then the story has served its purpose. Let the next words become softer. Let the information move farther away. You do not need to remember the difference between circadian rhythms and sleep pressure. You do not need to remember the names of brain regions. You do not need to remember the scientific details. You only need to rest. The brain can handle the rest. Your body can handle the rest. Tomorrow can handle itself. For now, there is only darkness, a quiet room, a resting body, and the slow passage of time. Your breathing continues, in and out. The rhythm does not need to be forced. Let it happen naturally. Your eyelids can become heavier. Your face can soften. Your shoulders can drop. Your hands can become still. And your mind can stop trying to hold every thought. Thoughts may appear. Let them. Thoughts may disappear. Let them. There is nothing you need to solve tonight. Nothing you need to prove. Nothing you need to finish. Sleep does not require effort. It requires release. So release the day. Release the plans. Release the conversations. Release the questions. Let tomorrow remain somewhere beyond the darkness. Your body has waited all day for this period of stillness. Now it can have it. And as the night continues, your brain can move through its quiet cycles. Light sleep, deep sleep, REM sleep, back again, over and over, each cycle carrying you farther into the night. You may never consciously notice the transitions. That is part of their beauty. The brain performs them without asking permission. And somewhere between one cycle and the next, consciousness may become quieter still. The room may disappear. The body may disappear from awareness. The sense of time may disappear. And for a while, there may be nothing you need to know. Only rest. Only darkness. Only sleep. So let the voice continue in the background if you wish. Or let it disappear completely. You are allowed to stop listening. You are allowed to drift. And you are allowed to sleep. The night is long. The world can wait. Your body knows the way. And now, gently, you can follow it. And as the night continues, the sleeping brain moves quietly from one state to another, carrying you through a rhythm that you rarely notice. You may be completely unaware of the transitions happening inside you, yet every few minutes, countless neurons are changing their activity. Different networks are communicating in new patterns, and your body is adjusting itself to the changing depth of sleep. The remarkable thing is that none of this requires your attention. You do not have to tell your brain when to enter deep sleep. You do not have to instruct your heart to slow down. You do not have to remind your body to regulate its temperature. You simply become still, and your biology takes over. This automatic nature of sleep is one of its greatest mysteries. During waking life, so much depends on conscious effort. You decide when to stand. You decide where to walk. You decide what to say. You decide what to eat. You decide what to focus on. But sleep removes much of that control. You cannot command yourself to fall asleep by force. In fact, trying too hard can sometimes make sleep more difficult. The harder you think about sleeping, the more alert you may become. The brain begins monitoring itself. Am I asleep yet? How long have I been awake? What time is it? How many hours are left? Will I be tired tomorrow? Each question creates another piece of mental activity. Sleep, meanwhile, is asking for something much simpler. Let go. Stop monitoring. Allow the process to happen. This is one reason relaxation can be so useful before sleep. Not because relaxation is a magical switch, but because reducing stimulation allows the natural sleep systems to operate without as much interference. Your body already knows how to sleep. It has been doing it for your entire life. You don't need to learn the basic process again tonight. You only need to give it an opportunity. And once sleep arrives, the brain begins another fascinating process involving its communication with the rest of the body. During the day, your brain is constantly receiving information from your muscles, organs, skin, eyes, ears, and internal systems. At night, the flow changes. External information becomes less important. Internal information remains. The brain continues monitoring the condition of the body. It can detect changes in temperature, changes in blood chemistry, changes in pressure, changes in energy availability. The body is still communicating with the brain, even when conscious awareness has disappeared. This communication is essential because sleep does not mean the body stops responding to its internal environment. Quite the opposite. The sleeping brain remains highly connected to the body's basic needs. One particularly interesting system is the hypothalamus. This small region deep within the brain helps regulate many fundamental processes: body temperature, hunger, thirst, hormones, circadian rhythms, and sleep-wake states. It acts as a kind of control center connecting the nervous system with the body's internal environment. Within this small region are systems that help promote sleep and others that help maintain wakefulness. These systems interact continuously. When wake-promoting activity decreases and sleep-promoting activity increases, you begin drifting towards sleep. It is not a simple switch. It is more like a balance. One side becomes stronger, the other becomes quieter, and eventually, sleep wins. Then, later, wakefulness returns. This balance explains why sleep can feel almost irresistible after a long period of being awake. The longer you remain awake, the stronger sleep pressure becomes. One important molecule involved in this process is adenosine. Adenosine accumulates in the brain during waking. As it builds, it contributes to the feeling of sleepiness. The longer you remain awake, the greater the pressure becomes. Then sleep allows that pressure to decrease. This creates a fascinating cycle. Wakefulness builds sleep pressure. Sleep reduces it. Then waking begins again. Your body is constantly moving between these two states. Coffee interacts with this system in an interesting way. Caffeine can temporarily reduce the feeling of sleepiness because it blocks adenosine receptors. The adenosine is still there. Caffeine simply makes it harder for the brain to detect its signal. This is why caffeine can make you feel more awake without actually eliminating the biological need for sleep. Eventually, the effect wears off, and the underlying sleep pressure can become noticeable again. This is one reason a person may feel suddenly exhausted when caffeine wears off. The sleepiness did not appear from nowhere. It had been waiting underneath the stimulation. And this is also why caffeine timing matters. Caffeine has a relatively long half-life. Depending on the individual, a significant amount can remain in the body many hours after consumption. So a cup of coffee in the afternoon may still influence the brain at bedtime. Some people are much more sensitive than others. Genetics, metabolism, habitual caffeine use, and individual biology all influence the effect. This is another reminder that sleep is personal. There is no single sleep experience shared perfectly by every human. Some people fall asleep quickly. Others need more time. Some naturally wake early. Others naturally wake late. Some remember dreams frequently. Others rarely remember them. Some are sensitive to tiny amounts of light. Others can sleep through almost anything. The underlying biology is shared, but the details vary. Age is one of the strongest influences. As people grow older, sleep architecture changes. Older adults generally spend less time in deep, slow-wave sleep than younger adults. Sleep can also become more fragmented. People may wake more frequently during the night. They may become more sensitive to environmental disturbances, and their circadian rhythms can shift earlier. This does not necessarily mean older people need dramatically less sleep. The amount of sleep needed does not decline as sharply as many people assume. Instead, the ability to maintain long, uninterrupted periods of sleep can change. This is an important distinction. A person can spend the same amount of time needing sleep while experiencing more interruptions. The result may be a different subjective experience of the night. Sleep also changes during pregnancy. Hormonal changes can influence sleepiness and sleep quality. Physical discomfort can make certain positions difficult. The growing body can make nighttime awakenings more frequent. Later in pregnancy, movement from the baby can also interrupt sleep. The sleeping body is therefore constantly responding to changing physical circumstances. Again, sleep is not isolated from the rest of life. It responds to the body. The body responds to sleep. The relationship goes both ways. Another interesting phenomenon is how sleep can influence emotional memory. Imagine experiencing something emotionally powerful during the day. Perhaps something exciting, something frightening, something beautiful, or something deeply disappointing. Your brain does not simply store the event as a neutral recording. Emotion changes the way memories are processed. During sleep, emotional experiences can be revisited and integrated. Some theories suggest that sleep helps separate the emotional significance of an event from the raw intensity of the experience. This may allow a memory to remain important without producing the same level of emotional activation every time you think about it. This is one reason an upsetting event can sometimes feel less overwhelming after a night of sleep. The event has not disappeared, but your relationship with it may have changed. Sleep creates distance, and sometimes distance is exactly what the brain needs. Dreams may also reflect this emotional processing. People often dream about emotionally significant experiences, but dreams rarely reproduce events exactly. Instead, they can combine fragments. A familiar person may appear in an unfamiliar place. A recent event may mix with an old memory. An emotion may appear without an obvious story. Dreams are not necessarily literal messages. They are experiences generated by a brain operating under unusual conditions. The dreaming brain can combine information in ways that waking consciousness normally would not. This can create stories that seem completely logical while you are dreaming and completely bizarre after waking. Perhaps you have experienced this yourself. In the dream, everything makes perfect sense. Then you wake up, and suddenly you realize that the entire story was impossible. A person was simultaneously two different people. A house had rooms that could not physically exist. You were somehow in two locations at once. And yet while dreaming, you accepted it. This reveals something fascinating about the brain. Our sense of reality depends partly on continuous reasoning and sensory feedback. During dreaming, those systems operate differently. The brain can create a convincing world from internal information alone. And for a few moments, that internal world can become your entire reality. Another strange feature of dreams is that they can include people who have been absent from your life for years. A childhood friend, a former teacher, a relative, someone you barely remember. The sleeping brain has access to enormous amounts of stored information. Memories that seem forgotten may still leave traces. Dreams can sometimes activate those traces. This does not necessarily mean the person or memory has special significance. Sometimes the brain simply draws from whatever information is available. Dreams are not required to have a single interpretation. They may be products of memory, emotion, perception, and spontaneous brain activity interacting together. And because the sleeping brain is not receiving the same continuous sensory information as the waking brain, it has more freedom to construct its own environment. This is why dreams can feel so immersive. You are not merely watching a movie. The brain is generating the experience from within. Sight, sound, movement, emotion, and sometimes touch, all can be represented. The dream world is a simulation produced by your own nervous system. And perhaps the most remarkable part is that you usually accept the simulation without questioning it. Until you wake. Then the simulation dissolves. The room returns. The bed returns. The ceiling returns. Your name returns. Your location returns. And the dream becomes a memory. Sometimes it disappears within seconds. This rapid forgetting is extremely common. You may wake with a vivid dream in your mind, then reach for your phone, and suddenly realize you cannot remember what happened. The dream has vanished. This may happen because memory formation during REM sleep differs from waking memory formation. The chemical environment of the brain is different. Certain neurotransmitter systems are altered, and the information may not be stored in a way that makes it easy to retrieve later. This is why dream journals can be useful for people who want to remember their dreams. Writing immediately after waking can preserve details before they fade. But for peaceful sleep, there is no need to remember anything. Forgetting dreams can be part of the normal process. In fact, forgetting may sometimes be beneficial. Imagine waking every morning with perfect memory of every dream you had. Your mind could become crowded with countless strange scenes. Instead, most dreams dissolve. Only fragments remain. A face, a feeling, a location, a sentence, a strange image. The brain moves forward. This selective forgetting keeps waking consciousness focused on the present. Another remarkable sleep phenomenon is the way memories can become reactivated during slow-wave sleep. Researchers have observed bursts of activity known as sleep spindles. These are brief periods of rhythmic brain activity that occur during non-REM sleep. Sleep spindles are particularly interesting because they appear to be involved in communication between brain regions. They may help coordinate the transfer and stabilization of memories. During deep sleep, slow oscillations, sleep spindles, and hippocampal activity can interact. Together, these rhythms may create windows in which recently learned information is reorganized. It is almost like the brain has its own nighttime communication network. Messages are sent, information is replayed, connections are adjusted, and memories become gradually integrated. The entire process happens without conscious awareness. You do not hear the brain's internal conversation. You simply sleep. Another feature of deep sleep is that it becomes harder to wake you. A small sound may not be enough. Someone could move around the room. A door could close softly, and you might remain completely unaware. This reduced responsiveness is useful. It protects sleep from minor disturbances, but the brain still retains some ability to detect important signals. A sufficiently loud or meaningful stimulus can wake you. Parents sometimes become sensitive to their baby's sounds. A parent may sleep through traffic but wake immediately when a baby makes a particular noise. This is not necessarily because the baby is louder. The brain has learned that the sound matters. Meaning changes perception. Your sleeping brain is therefore not simply measuring volume. It is evaluating significance. This selective sensitivity is another example of how learning continues to influence the brain even during sleep. Your brain has priorities, and some signals are more important than others. The same principle can be seen with your own name. A person may sleep through conversations that do not concern them, but hearing their name can sometimes produce a stronger response. The brain recognizes familiar and meaningful patterns. Even during sleep, some of this processing remains active. This is one reason complete sensory isolation is not necessary for sleep. The brain can filter, it can ignore, it can monitor, it can prioritize, and it can return to deeper sleep, all while you remain unaware. Another important part of sleep is the glymphatic system. This is a network involved in the movement of fluid through brain tissue and the clearance of certain waste products. Research suggests that this system becomes more active during sleep, particularly during certain stages. The idea is fascinating. During waking hours, the brain is busy processing information. During sleep, conditions may become more favorable for fluid movement and waste clearance. This does not mean the brain becomes washed clean every night in a simple sense. Biology is more complicated, but sleep clearly plays a role in maintaining the brain's internal environment. The brain is metabolically demanding. It consumes a large amount of energy. Its cells produce metabolic byproducts. Those byproducts need to be managed. Sleep provides a state in which some aspects of this maintenance may occur more efficiently. So while your mind appears to be doing nothing, the brain is engaged in housekeeping. It is cleaning, organizing, regulating, repairing, and preparing for another day. This is why sleep deprivation can eventually affect cognition. If maintenance is repeatedly interrupted, the system becomes less efficient. The brain may still function, but it has fewer opportunities to restore balance. And eventually, the consequences become noticeable. Attention becomes unstable. Memory becomes less reliable. Mood becomes more fragile. Reaction time slows. Motivation changes. And the world begins to feel heavier. Sleep is not merely the absence of tiredness. It is the process that allows tiredness to be resolved. And now, perhaps, you can feel your own body becoming quieter. Maybe your breathing has slowed naturally. Maybe your eyes feel heavy. Maybe your thoughts have begun wandering away from the story. If so, you do not need to bring them back. Let them wander. The purpose of these words is not to keep you awake. It is to give your mind something gentle enough to follow until it no longer needs to follow anything. You can let the sentences become less important. You can let the details disappear. You can stop trying to understand every scientific idea. Your brain can continue without your supervision. There is nothing you need to solve tonight. Nothing you need to remember tomorrow. The world will still be here in the morning. For now, you can simply rest. The darkness around you can become softer. The weight of your body can become more noticeable. Your muscles can remain still. Your thoughts can become slower. And somewhere beneath conscious awareness, the next sleep cycle may already be beginning. Perhaps slow waves are moving across your brain. Perhaps your memories are being quietly reorganized. Perhaps your body is regulating its temperature. Perhaps your heart is beating more slowly. Perhaps you are already drifting between thoughts. You don't need to know. You don't need to check. You don't need to measure. Just allow it. The night is not asking you for anything. There is no deadline here. No notification. No appointment. No decision. Only darkness. Only quiet. Only the slow rhythm of breathing. And the gentle biological process that has carried humans through countless nights before you. Soon, even these words may become difficult to follow. A sentence may begin, and before it ends, your attention may disappear. That is okay. Let it disappear. Another thought may arrive. Let that one disappear too. You do not have to hold on to anything. Sleep is not something you have to catch. It is something you gradually stop resisting. So let the day become distant. Let tomorrow remain far away. Let your body become heavy against the bed. and let your mind become quiet. The brain knows what comes next. The body knows what comes next. You can simply allow the night to continue. Slowly, naturally, silently. And if you fall asleep now, there is nothing more you need to hear. The story can continue without you. The science can wait. The morning can wait. Everything can wait. For now, rest. And let sleep carry you gently into the next quiet hour. And now, as we reach the final quiet stretch of our journey, there is perhaps no better place to end than with the simplest truth about sleep. You do not have to understand it completely to experience it. Every night, your body enters a state that scientists have spent generations trying to understand. We can measure brain waves. We can observe eye movements. We can monitor heart rate. We can track hormones. We can study memories. We can examine dreams. We can watch changes in breathing and body temperature. And yet, after all of this research, the personal experience of falling asleep remains wonderfully mysterious. You close your eyes, the world slowly disappears, and then, at some point, you are simply gone from waking awareness. There is no alarm announcing the moment, no sound telling you that you have crossed the boundary. Your thoughts simply become less organized. Your surroundings become less important. Your awareness becomes softer, and sleep takes over. One of the most beautiful things about sleep is that it happens without requiring conscious understanding. A baby does not need to understand circadian rhythms. An animal does not need to understand sleep pressure. A person does not need to know what a sleep spindle is. The biological system already knows what to do. Sleep evolved long before humans began studying it. And that means your body carries an ancient biological program that is older than language, cities, books, technology, and almost everything else we associate with human civilization. Every night, you participate in that ancient rhythm. Darkness arrives. Activity decreases. The body becomes quieter. The brain changes its patterns. And rest begins. Perhaps the strangest part is that modern life can make us forget how natural this process is. We treat sleep as something that has to fit between everything else. Work comes first. Responsibilities come first. Messages come first. Entertainment comes first. Then, when everything else is finished, we hope there is enough time left to sleep. But biologically, sleep was never designed to be an afterthought. It is one of the foundations supporting everything else. Your ability to think depends partly on sleep. Your ability to learn depends partly on sleep. Your ability to regulate emotions depends partly on sleep. Your physical recovery depends partly on sleep. Your attention depends partly on sleep. Your immune system interacts with sleep. Your metabolism interacts with sleep. Your cardiovascular system changes during sleep. Your memories are processed during sleep. So many things that happen while you are awake depend on what happened while you were unconscious. This creates a beautiful cycle. You sleep. Your body prepares you for waking. You wake. You experience the world. You learn. You move. You work. You laugh. You worry. You remember. Then you sleep again. The next night, the process begins once more. It is a rhythm that accompanies the entire human lifespan. And the rhythm changes as you change. When you are young, sleep can occupy a huge portion of your life. As you grow, your sleep becomes more consolidated. During adolescence, your biological timing shifts. During adulthood, responsibilities begin competing for your nighttime hours. Later in life, sleep architecture changes again. But throughout all of these stages, the need for rest remains. Sleep changes shape. It does not disappear. Another beautiful idea is that sleep gives the brain permission to stop responding to everything. During waking life, there is always something asking for attention. A sound, a notification, a thought, a responsibility, a person, a memory, a problem. Even silence can sometimes contain thoughts demanding attention. Sleep creates distance. For several hours, most of those demands no longer matter. The phone can remain untouched. The messages can remain unanswered. The unfinished work can remain unfinished. The decisions can wait. The brain can step away. And perhaps this is one of the most valuable things sleep gives us. Not only physical restoration, but temporary freedom from responsibility. You do not have to be productive while asleep. You do not have to improve yourself. You do not have to accomplish anything. You simply exist, and the body does the work. This is especially important in a world where productivity is often treated as a measure of personal value. Sleep reminds us that being still is not the same as being useless. Rest is not wasted time. Quiet is not laziness. And doing nothing consciously can allow countless things to happen biologically. While you sleep, your brain continues processing information. Your body continues regulating itself. Your immune system continues functioning. Your heart continues beating. Your lungs continue breathing. Your cells continue their ordinary maintenance. The world does not stop. You simply stop participating in it for a while. And perhaps that is exactly what the human brain needs. A temporary retreat, a quiet interval, a place where the demands of consciousness become softer. There is also something comforting about the fact that sleep is shared across the living world. Birds sleep, cats sleep, dogs sleep, elephants sleep, dolphins sleep, bats sleep. Even animals with very different nervous systems have developed their own forms of rest. Sleep appears in many shapes throughout nature. Some animals sleep for long periods. Others sleep in short episodes. Some can rest one side of the brain while remaining partially alert. Some sleep while floating. Some sleep while standing. Some sleep in groups. Some hide themselves. Some remain exposed. But the underlying principle remains remarkably consistent. Living systems need periods of reduced activity and altered brain function. Sleep is not a strange human weakness. It is a deep biological necessity. And perhaps this makes the darkness around you feel a little different. You are not doing something unproductive. You are participating in one of the oldest rhythms of life. The same planet that turns beneath the stars is turning tonight. Darkness is moving across different parts of Earth. While one person is waking, another is working, another is eating, another is traveling, another is dreaming. Millions of people are lying quietly in beds. Millions of animals are resting in forests, oceans, fields, cities, and deserts. The world is filled with sleeping life, and you are part of it. Another remarkable thing about sleep is that it gives us a temporary experience of not knowing. During the day, we are constantly trying to know. What time is it? What happened? What will happen? What should I do? Where should I go? What does this mean? Sleep removes many of those questions. For a while, you don't need to know. You don't need to know what time it is. You don't need to know what tomorrow will bring. You don't need to know what happened somewhere else in the world. You don't need to know what anyone else is doing. You can simply stop asking. And perhaps that is why darkness can feel so peaceful. It reduces information. The eyes close. The environment becomes less visually demanding. The brain receives fewer signals. The world becomes smaller. A room, a bed, a blanket, a quiet breath. And gradually, even these things can disappear from conscious awareness. This is the doorway into sleep. The strange moment when the world no longer needs to be observed. Your brain can stop building a detailed model of the environment. It can turn inward. It can begin its nightly work. And while you are asleep, something else happens that is easy to overlook. You lose your sense of time. A few hours can feel like moments. You close your eyes, and suddenly it is morning. There may have been thousands of heartbeats between those moments. Countless breaths, multiple sleep cycles, changes in brain activity. changes in hormone levels, changes in temperature, and yet subjectively, it may feel like nothing happened. That compression of time is one of the most fascinating experiences of sleep. The hours exist, but you do not experience them in the ordinary waking way. You simply disappear into them. Then morning arrives. The brain begins increasing alertness. Body temperature begins rising. Hormonal patterns shift. The senses become more responsive. Awareness returns. And once again, the world appears. You may hear birds, traffic, a heater, an air conditioner, someone moving through the house. The sounds that were irrelevant during sleep suddenly become meaningful again. Your eyes open. Light enters. The brain recognizes the room. And slowly, the story of yourself returns. Where you are, what day it is, what you need to do, who you are. The continuity of consciousness returns. But something has changed. You have passed through another night. You have given your brain another opportunity to process, to regulate, to recover, to reorganize, to rest. And even if you do not consciously notice every benefit, the process has happened. This is why sleep is so deeply connected with memory. You may wake remembering nothing unusual, but the brain has still been active. Not remembering the work does not mean the work did not happen. It is similar to maintenance performed inside a machine. You do not see every adjustment. You only notice that the system continues functioning. Sleep works in much the same way. Its effects are often invisible. You simply notice the result. A clearer mind, a steadier mood, a little more energy, a little more patience, a little more ability to concentrate. Sometimes the difference is dramatic. Sometimes it is subtle, but the nightly process continues. And perhaps one of the most important lessons from sleep science is that you should not judge your sleep solely by whether you remember dreaming or whether you woke feeling perfect. Sleep is complex. There can be brief awakenings you never remember. There can be changes in sleep stages that you cannot feel. There can be variations from one night to another. One unusual night does not necessarily mean something is wrong. Your sleep naturally changes. The important thing is the overall pattern. And if you are listening to this tonight because you are awake, remember that being awake for a little while is not automatically a disaster. Sometimes the more frightened we become about being awake, the more alert the brain becomes. You do not need to fight the night. You do not need to force yourself into sleep. You can simply rest. Resting quietly is already different from actively working. Your muscles can relax. Your eyes can remain closed. Your breathing can slow. Your environment can become quiet. And eventually, sleep may arrive naturally. You don't need to chase it. Perhaps the best thing you can do is stop checking whether it has arrived. Stop measuring. Stop calculating. Stop judging. Let the night be the night. If sleep comes quickly, let it come. If it takes longer, remain gentle with yourself. The brain responds poorly to pressure. It responds better to safety and quiet. So allow yourself to be imperfect tonight. You don't need perfect sleep. You don't need a perfect routine. You don't need a perfectly silent room. You don't need to control every thought. You only need to give your body the opportunity to rest. And now, as this long journey through sleep comes toward its final moments, perhaps the facts themselves can begin disappearing. You do not need to remember the names of brain structures. You do not need to remember the chemistry. You do not need to remember the stages. You do not need to remember the strange dreams. You do not need to remember any of this tomorrow. Let the information dissolve. Let the words become background noise. Let your attention become softer. Perhaps you can notice the weight of your head against the pillow, the warmth beneath the blanket, the gentle rise and fall of your breathing, the quiet rhythm of your heartbeat. You don't have to change anything. Just notice, and then let even that awareness fade. Your body can become heavier. Your face can soften. Your jaw can relax. Your shoulders can sink. Your hands can become still. Your legs can become comfortable. Your thoughts can become slower. There is nowhere else you need to go. Nothing else you need to accomplish. The day is finished. Tomorrow can wait. The unfinished tasks can wait. The unanswered questions can wait. The future will still be there when you wake. For now, you can remain here in the quiet. And somewhere beneath your conscious thoughts, your brain may already be beginning another transition. Wakefulness fades. Sleep approaches. The boundary becomes thinner. The room becomes less important. Your thoughts become less organized. Perhaps an image appears. Perhaps a memory. Perhaps nothing at all. And that is okay. You don't need to control what happens next. Let the mind wander. Let it become strange. Let it become quiet. Let it disappear. Soon, the voice may become nothing more than a distant sound. The words may lose their meaning. You may hear only fragments. Then even the fragments may disappear. And eventually, there may be no story at all. Only sleep. Only darkness. Only the quiet rhythm of your body continuing its ancient work. And while you sleep, the world will continue turning. The earth will continue moving through space. The stars will remain above the atmosphere. The oceans will continue their slow movements. Trees will continue releasing and absorbing gases. Animals will continue resting and waking. Somewhere, dawn will already be approaching. But you don't have to follow it yet. You can remain in the night. You can remain still. You can rest. Because the morning will come on its own. You don't need to bring it closer. You don't need to prepare for it tonight. Your only task now is to let go. Let go of the day. Let go of the story. Let go of the facts. Let go of the thoughts. And let sleep do what it has always known how to do. Carry you somewhere quiet. Somewhere without deadlines. Somewhere without notifications. Somewhere without questions. A place where time can pass without needing to be counted. A place where the mind can become silent. A place where the body can recover. And perhaps, as these final words become softer, you are already somewhere between listening and dreaming. If so, stay there. Don't come back. There is nothing else you need to hear. You have learned enough for tonight. The rest can wait. Close your eyes if they are not already closed. Breathe gently. Feel the bed beneath you. Feel the darkness around you. And allow yourself to become completely still. The night is safe. The room is quiet. Your body is resting. Your mind can finally let go. And as the last sentence fades away, there is nothing left to understand. Nothing left to remember. Nothing left to accomplish. Only sleep. Deep, quiet, gentle sleep. Good night. And let the science of sleep continue without you.